Okay, Assalamualaikum everyone. So today we will talk about experiment 3C and 4C, which is a separating mixture. But before that, we will start our live stream with recitation of Ummul Kitab Al-Fatihah. Okay, so today live stream is about separating the mixture from the organic solvent. Okay, during the live stream, you can ask me any question if you want to related to this experiment. And also during the live stream, I will ask you a few questions. So whoever can answer that, you get some marks. When you want to answer the question, please state your name and then state your name first and then you answer the thing so that I know who is who. What else? So I hope this live stream will be less than 2 hours. So without further ado, let's start about this experiment 3C and 4C separating the mixture. Okay, in front of you now, you can see the plan that we will do today. So I want you to comprehend this whatever in front of you now for a while. Just what we call try to understand what's going on, because it's quite a lot of stuff going on here. Actually, this experiment will cover in the physical lab. This experiment is 2 weeks experiments. So now we compress it in just less than 2 hours. So take your time and please read for a while before we start with our virtual experiment. Can you see the thing? Can you see in front? Can you see clearly?
Yes, sir.
You can see, huh? You can zoom in or zoom out later on. Okay, if you look at this plan, you will see this experiment cover three. You will learn about few things in this experiment. You will learn about, let's see. Okay, in this experiment, you will learn about how to perform a liquid-liquid extraction, how to perform precipitation, recrystallization. You have learned this before in the previous live stream, but this time maybe we will learn about a different type of recrystallization. Last week, last stream, we learned about the single solvent recrystallization where you use water only. But today we will learn about the mixed solvent recrystallization where you use water and methanol together. And then you also learn about distillation. You will also learn about the sublimation. Along the way, you will be what we call introduced to drying agent and also boiling stones. Okay, let me make it smaller. Okay, if you look here, there are not three stage, but basically the plan is like this. First, we will have acid, base and neutral. There are 3 different organic solvent, organic compound. You mix them together in a solvent. When you mix them, it's like it becomes a solution. It's a mixture. It's like when you make water, when you make sugar in water. So sugar is inside the water. Same like here, we want to add acid, base and neutral into the DCM. DCM stands for Dichloromethane or methylene chloride. This is organic solvent. You will see later on what is this. But the idea is that you will use this instead of water to mix all these things, acid, base and neutral. When you have that mixture, later on you will separate them. Okay, you want to get back acid alone, base alone and neutral alone. So that's the main idea for this. You want to separate a compound from a mixture. So you will learn first about the liquid-liquid extraction here. So you will introduce with the separating funnel and so on, and then you will learn about, so you will do liquid-liquid extraction for the acid, for the base, and also for the neutral here. Okay, so that is extraction. But then when you want to isolation is different. Extraction is just you take out, for example, later on you have a beaker with an acid inside that, but you want to remove the water or whatever, you just want the acid. So then later on you will learn about how to do precipitation, recrystallization, and you have learned before, but we will show about how to do mixed solvent recrystallization. And for the base, you do also liquid-liquid extraction. And then after the extraction, you get a base, and then you will be introduced to what we call distillation process. Okay, distillation process. Okay, and then you do the distillation, and then you measure melting point. This MP is melting point. But we will not perform the melting point experiment. I just put here just to show you what actually should be done lah. But we will not perform this because you have learned this in the live stream number 1. And at the end, we also perform the liquid-liquid extraction for the neutral sample. Okay, and during this separation of neutral compound, you will learn about the evaporation process. No, you will not learn this. It's just you know that thing, what is evaporation, and then you will learn about the how to do sublimation process. The sublimation process. So basically, that is the idea for today's experiment. The long part here is basically the liquid-liquid extraction. Okay, liquid-liquid extraction. Okay, but at the end of the day, you will learn all of this: liquid-liquid extraction, precipitation, recrystallization, distillation, sublimation, drying agent, boiling stone, and so on. So from time to time, before I switch to the virtual camera, from time to time I will refer back to this diagram, so that you will understand, you will know where you are. Okay. Sometimes people get lost in this, a lot of steps. Okay, let me change the camera now. Okay. 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 Wait, I need to change this thing. Configure video. Okay, can you see in front of you? There are like 3 bottles of chemical. Everybody can see these 3 bottles of chemical.
Yes, sir.
Okay. Yes, sir.
Okay. So let me put it. Is it clear? Maybe not clear, but it's okay. Okay, so this is the chemical that we will use to perform our experiment. We have an acid here. This is benzoic acid. This is camphor powder, and this is p-chronoaniline. Okay, but before we do anything, let me wear my glove first. So this glove is S. I think it's quite. In the lab, make sure you wear the proper, what we call, proper size glove. There are typically 3 size of the glove, L, M, and S. This is S. The reason why you need to choose the proper size is that it's easy for you to work with other stuff lah. If you use the like not fit your size, maybe it will like slip, your stuff will be slip during handling and so on. Okay, so now I am wearing my glove. So how to start? Okay, so this is benzoic acid. So if you look inside the benzoic acid, it's just like what we call, it's just a powder, a white powder like that. Okay, just acid. In the previous live stream, we learned about the salicylic acid. It's more or less like that. But this benzoic acid have this what we call the structure like this. You will learn in the organic chemistry something called aromatic compound. So benzoic acid is the simplest aromatic carboxylic acid. Okay, what make this acid is because you have benzene there, and then you have what we call this functional group COOH. So this is basically what make this thing acid. Okay, and then you have the base on the other side there. So here P4-chloroaniline. Okay, so basically it's also like a benzene like this. It's a benzene, but then you have this functional group, the amine functional group, NH2, and at the bottom you have this like CH3 thing. Okay, so the amine group here is what contribute the basicity of this base. In your lab report, you will see this is called P-chloroaniline. But here, if you, I don't know whether you can see or not, maybe it's not very clear there, but this is called 4-chloroaniline. It's the same thing. Okay, so the P in your lab manual is stand for para. Okay, so this is basically configuration of para, where you have the amine at the position number 1, and then 2, 3, and 4. So this is para. So you will learn this in detail in your organic chemistry class later on with your instructor. And then you have the camphor there. So the camphor here is neither acid or neither base. So we have the structure of, I think, like this code, like this, then like this CH3, and then CH3, and then you have this what we call this O, and then you have CH3. So if you look here, there are neither the acid or base functional group on this camphor. So the camphor here in Malay we call it kapur barus. People use this to what we call to mummify the dead. Okay, and also it has quite a good smell. It's a smell, actually smell for, if you ever know this thing, minyak angin cap tapak, for those who are local here, those who are like Malaysian here, so most of you know how this smell. So this is basically the smell of camphor. Okay, if you look in this ingredient there, you have like camphor there. I don't know whether you can see or not, but yeah, whatever, but yeah, there are camphor there. So there is camphor there. Okay, so and also camphor nowadays also used to what we call to they serve it as a like mothball. MOTHBALLS. Okay, mothball. Okay, because this camphor is toxic for the insect. Okay, so that's why you put in your wet drop to avoid the insect coming and ruining your shirt and clothes, so on. Previously we used this. Previously people use this naphthalene ball. Okay, naphthalene ball. Previously is naphthalene ball. Naphthalene is basically, if you see the naphthalene itself, the structure is like this. You have this and this. You have benzene and you have another benzene. You have two benzene combined together. This is naphthalene. Okay, this is naphthalene. But the problem with this is quite toxic, and they are in Europe they already banned this. That's why people nowadays they use this instead of this naphthalene ball. Okay, one thing about this moth ball is that when you put in your wet rope with whatever place, it will disappear over time, because this camphor can sublimate. Later on we will learn about sublimation. Sublimation is basically the process of solid going to gas without going to the liquid phase. So that's why when you have this ball, you put in your wet rope, over time it will be disappear without leaving any trace, because the solid become gas straight away. So enough for that. So the idea now, we will combine all this together into a mixture, but you cannot combine this in using water, because one of the key point that you need to learn, let me go to this first. Look here. One of the key idea, if you look here, this is one of the key idea in this experiment. Okay, let's see here first. One of the key point. The first key point, most organic compound doesn't dissolve in water. Previously, we see in the previous live stream, we learned about the salicylic acid that can be dissolved in water. But most organic compound doesn't dissolve in water, but it's able to dissolve in organic solvent, okay, other than water. Okay, so we will use the organic solvent here. We will use dichloromethane. Okay, dichloromethane is basically heavier than water, and this is important when you want to do the liquid extraction later on. Just bear in mind for time being, dichloromethane is an organic solvent, and it is heavier than water. Okay, why we need to know this is because later on when we do liquid extraction, the name itself liquid, you need to use a 2 liquid. Okay, you need to use 2 liquid. So we will use dichloromethane as one of our liquid. Okay, so that's two first key point that you need to know. So let's go back to our test. Okay, so I already put everything here, combine this all thing here inside this flask. Inside this flask, I already put all this flask. And the reason why I seal this is because, as I said before, camphor is able to sublime, meaning that from solid going to gas. So you need to hold, you need to like prevent that to happen. Okay, prevent that to happen. So that's why I seal this glass. Okay, so inside this we already have what we have. We have okay, we start here. Okay, wait, slow, relax. So now you see we have acid, benzoic acid, we have base, p-chloroaniline, and we have a neutral, the camphor. So we want to put into the flask. So we put 0.2 gram of each of that. So inside here there are already 0.2 of acid, 0.2 of base, 0.2 of neutral. Inside this also I already put 0.2 of acid, 0.2 of base, 0.2 of base. We will see what happens if, let's say, one flask I put water, one flask we put organic solvent, which is dichloromethane. Okay. So now we're done with this stuff, this prop. So I can just put somewhere else because I need space. Where is dichloromethane? Where is my dichloromethane? My dichloromethane. Oh, it's over there. So I need to go somewhere over there to the sinks because my dichloromethane is there. But for the time being, please remember this. Please remember this structure. Okay, I'm back. So this is basically dichloromethane. I already put in the what we call glass bottle. There. Dichloromethane is a organic solvent. Okay. And some organic solvent is quite hazardous and is quite not good for what we call. If, for example, like this, if you see here, there are some what we call some plastic melt here. It's because I accidentally have some dichloromethane here, and then I put here, and it's like what we call, it's melt the plastic. The dichloromethane melt the plastic here. So that's why people use glass. Okay, glass is good. I mean, it's not react with the glass. So that's why most of the good thing, if you want to deal with the chemical, most of the chemical they put in the glass. Okay, some chemical doesn't do this thing, but certain chemical do something like this. Because this dichloromethane, if you look this here, dichloromethane itself, dichloromethane. Okay, the other name for dichloromethane is what we call methyl chloride. Methyl chloride. Okay, so basically it have the carbon. You learn the organic chemistry. I think most of you taking the organic chemistry concurrently with this lab session. So you have this C, you have dichloro, so you have 2 chlorine, and then methane. You have this lah. So this dichloromethane. Okay, so this simple structure enough to make things like this. Melt the plastic. Okay, so now we want to mix this, our sample here, with dichloromethane. One with the dichloromethane, one with the water, to see our first key point that I said before, where I said that the most organic compound dissolve in organic solvent but not in a water. So I will move this, but before that let me swipe this first. Okay, so we have this. Let's say I open this. Basically, if you have any question throughout this live stream, you can just ask. Okay, and the most important thing when you deal in the lab, when you work in the lab, is to label. Okay, here I already label my what we call my my flask. So because most of the organic solvent is colorless, if you don't label it, then you don't know which one is which. It's very common that people make mistake by not labeling the stuff. They want to do it, they want to perform their experiment fast, but at the end of the day, they ruin the result. I mean, they don't know which result belong to which, and they need to repeat again. So takes time to label your sample or whatever you do. Okay, so I have water here. So, and we use our pipette here. You have seen pipette before. This is 10 ml pipette. We will put 10 ml of water here and 10 ml of dichloromethane here. So we have this pipette tip. Even this pipette tip, you must level, because when you want to deal with this water, you use one pipette tip. But when you want to use another solvent, for example DCM later on, you need to use another pipette tip, because if you use the same pipette tip, it will contaminate the solvent or your water. Okay. Okay, so this water, so let me take it there. So as usual, I set to 10 because I want to put 10 only. Okay, so I just put there, then there, and then close. Do one by one, don't rush, because if you rush, then things happen. So take out, put there, and then I take the DCM pipette tip. It's just a simple pipette tip, just I label it, and then we put water over there. We take the dichloromethane. Dichloromethane. Sorry? Any question? Okay. I mean, it's good. I mean,
Sir, in both flasks you put the methylene chloride?
No. No, this is water.
Okay.
This is methylene chloride. The reason is that we want to see our first key point here, because I said before that here I said, where is the thing? Our key point takes away home is just this thing. We want to prove that. Okay, we want to prove the first key point. Most organic compound don't dissolve in water, but dissolve in organic solvent. So that's the idea actually. So now let's go to the camera. So now you have this thing. Okay, so let me zoom the thing first. How to zoom? Here, I think this is zoom. Okay, maybe I put the black pepper over there so you can see it clearly. Okay, so this is water. This is water. So if you try to swirl it, I mean, you do it like for 1 day, it still doesn't dissolve. You see there are some what we call some leftover there. I mean, not leftover. Basically, that's the sample. The sample might dissolve. The sample might dissolve at certain portion only. Maybe like out of 100%, maybe 1% dissolve in water, but 99% not dissolve in water. When I said don't dissolve in water, it doesn't mean that it's 100%, completely 100% doesn't dissolve. It's not that. Because organic solvent have different solubility in water. For example, in the previous live stream, we learned about the salicylic acid. In the room temperature, it doesn't dissolve, right? But then when you ramp the temperature up to, I think, boiling point, then all the salicylic acid is dissolved. So meaning that the salicylic acid, being an organic solvent, doesn't dissolve in water at room temperature, but dissolve in water at high temperature. But certain compound doesn't do like that. Even at high temperature, it doesn't dissolve. Okay, so this water, this compound doesn't dissolve in room temperature, because when we want to perform the liquid-liquid extraction, we want to perform it at room temperature. So we want something that can dissolve, can mix our sample as if the water mix our sugar. It's like that. But here they are clump. Okay, so this our water. But here, if you look here, it's clear. So it's clear there. So I think it is clear there. So I think it's clear. So we give a gentle swirl. So you swirl gently, because why? Because if you swirl vigorously, some of undissolved sample will stick to the what we call on the side of this beaker on the top there. So it doesn't have a contact with your DCM. So that's why you swirl very slowly, so that every compound will be inside the DCM. Okay. So we're done with this water, so we can put somewhere over there. Okay. So now we have the mixture. So what we do now? So now inside this we have three things. We have acid, base, and a neutral compound. The idea for this experiment, today's experiment, is that we want to bring out that again separately. We want to get the acid in DCM bag. We want to get the base alone. We also want the neutral alone. We want to separate. We want to make one beaker. Here we want to have DCM and acid. We have here DCM and base, and we have, let me move this. And we want this is DCM with what we call with the neutral compound. So that's the idea, how to separate compound. If you look in the real life, for example, if you take the tree, like the camphor itself, the natural camphor, they extract it from the tree. But you know the tree contain a lot of stuff. You have like lignocellulose, you have this cellulose, you have this lignin and whatsoever. You want to extract that camphor only. So you need to find a way to extract that. So in this experiment, we learn some of the way to extract organic compound from the nature or from whatever lah. So this example of extraction is useful later on when you do final year project. For example, let's say you want to extract medicine drug from the leaf. So you can just you may use this method or other method and so on. But just to show you that this is one of the method to extract the compound from the mixture. So this is a mixture. Okay, what do we do next? Okay, any question?
The left side of the camera, I guess there is another camera is open. You can see.
I know, this side, right?
This side.
Yeah, I know. I just left it so that if I want to put it somewhere, so you can see from this.
Oh, okay, okay.
Yeah, it's just intentionally, but I'm not using it yet. That's the reason. So stay there. Don't do anything there. Okay, so we have this. So now what we do? We want to perform a liquid-liquid extraction. If you look here, if let's say I want to go back to this main PC, okay, if I go here, mana? Wait. Okay, where is the thing? Let me move there. How to go there? Okay, so if you look here, after we do after we mix everything, we want to put into a flask. Okay, we want to put into flask. The idea so now we will start the liquid extraction separation process. The idea of liquid extraction process is that, as the name imply, you have liquid. You have a liquid. You have two liquid. You have this liquid extraction. You have two liquid. Participating. Okay. So let's say I move to this back. Okay. Okay. Imagine now I have this empty bottle. Okay. Imagine I have this empty bottle. Inside this bottle, I put some water. So let's say I put some water there. So I put some water. So you see there are water there. And now I want to put an oil. So you know what happened when you put oil on the water, it will separate. Okay, so I put there. Let me close this oil first. Okay, so let me close this before anything happen. Okay, so you see in this oil and water, they mix, let me, wait, I need to change this thing. Oh, they are black there, so let me return back. Okay. Let me zoom this thing first. Where is the thing? I don't know where is the thing. It's okay. It's okay lah. Okay, so now in this water oil, you see that the oil and water is not miscible. This is basically what we call this two phase is not miscible. So you have water, you have oil there. So the idea of liquid extraction, you need to have two different liquid like this oil and water. And then let's say you have a solute. For example, let's say you have acid here, and this acid have more preference to go to the oil. So the idea is that when you do liquid extraction, for example, you want to bring the acid to the oil, so you just add the oil and then you shake it, and then the acid will go to the oil. So that's the idea of liquid extraction. Two things that is important. The first thing is that you need to have two immiscible solution, meaning that two solution that is not mixed with each other, because if these two mix together, then you cannot extract one from to another. And the second thing, you need to know about the density. You know here the oil is less denser than the water, so that's why the water is on the top. Here it's easy because you can see the color, but as I said before, most organic solvent is colorless. So if you don't know which one is which, then you will end up taking up, for example, let's say your sample is on the top, but then you take on the bottom. So then it will give you the wrong result. The dichloromethane here is heavier than water. So if let's say I mix the dichloromethane inside this, see what happened. Where is my dichloromethane? And then I take the dichloromethane and put inside this. What do you think will happen? Okay, the question time, 1%. What do you think will happen if I put the dichromethane inside this and then I mix all this thing together?
Okay, can I answer?
State your name because if not I not remember.
Okay, Bakil Abdurrahman.
Okay.
This one will be denser than the water, so it will be underneath the water.
Underneath the water. But what
Yeah.
happened now, Bakil? What happened now? If let's say, so that's true. You see now they are like there are 3 layers. There are oil. There are oil over there. There are water. There are like a dichromethane inside that. But what happened if let's say I shake this thing? Okay, what happened, Bakil?
They will separate again and wait, huh?
And then what?
Continue shaking. The idea is the thing will be dissolved in the compound, which is going to be more soluble to the water. Will go to the water. The more soluble to the methyl chloride will go to that one. Is that right?
Okay. So okay, that's right lah. So the idea is that, like I said before, that dichromethane is basically organic solvent. Then organic solvent is different polarity with our water, but the oil is basically is non-water loving. It's non-polar. It's basically non-polar, the oil. So dichromethane can sort of like what we call capture the oil. So this, if you left it for like 1 day, because it takes time, because now it's emulsion here. I don't know you can see clearly or not, but now, yeah, it's just mixed there. But if you left it for few times, let's say 1 hour, you get like this. You get something like this. So now you see the oil at the bottom now, because dichloromethane capture the oil. Okay, dichloromethane is heavier, but then the oil have more preference to go to dichloromethane than to the water, because the oil don't mix with water, right? Oil hate water. But the oil love dichloromethane because both are non-polar. So that's why now, instead of having 3 layers like before, 3 layers happen before is because we don't shake. Okay, so they are like it takes time for them to this. If you don't shake, then there are no meeting between each of them. But if you shake, they are sort of like the top will meet the bottom will meet the middle, and so on. So that's why now at the end of the day, if you add oil, water and dichloromethane, the dichloromethane will go bottom because it's heavier, and even though oil is lighter than water, but the dichloromethane will sort of like capture the oil and bring them together to dichloromethane. So this is the idea of liquid-liquid extraction. So in this case, imagine you have a sample, you have the oil in the sample, you can use dichloromethane or whatever, alcohol, whatever, to extract that from the water. Okay. So yeah, so that's the idea there. Okay, so now, but the problem, there are some problem here. Let's say you want to take the oil here. You want to take the oil at the bottom. Okay, the question. So now the question time. So how you want to take the oil from here? At the bottom. Question, give your name and answer that. Anybody?
Sir, can I try to answer?
Give name.
My name is Ali Fahimi.
Okay.
I think the way to take the oil out of the tube is by using a shrink.
Okay.
Then suck the oil using the shrink, I think.
That's one way. So one way to take the oil is that first you take the string and take out the water there, and then take another string and take the oil. But that's quite cumbersome. Okay, that's quite like you need to take another string and so on. So that's why we will introduce you to this thing, this stuff. So this is basically separating funnel. Okay, if you see, instead of making a string, better we put a hole at the bottom. We put a hole at the bottom here. Okay, so that's what the idea of this separating funnel. You have later on, you have 2 layers of whatever you want to do. Let's say you want to take the bottom one, because to take from the bottom is much easier than you take the string from the top, because from the top you need to know when to stop to what we call to suck the whatever you want. From the bottom is much easier because you can control it much easier than taking from the top. Okay. So here this is a separating funnel. You have this what we call stopper. Okay. We have this pear-shaped glass. So this is set funnel. The short form for this is set funnel or separating funnel. So this is stopcock. Okay. On the stopcock you have this what we call little knob here. So this little knob is used to tighten this thing, tighten this what we call the stopcock. Okay, and then you have your runaway glass outlet here. Okay, so the idea now is that in order to use this, you need to make sure that you first put in what we call in this horizontal position to close this thing, because if you look here, I don't know you can see or not. If I open that, if I open this, see, wait. If I open that, you see there are hole there. There are hole. Can you see or not? I don't know whether you can see or not.
I can see, sir.
Yeah, there are hole there. Okay. Okay, so there are hole there. I don't know whether you can see or not, but I hope you can see a hole, and then I close. So the thing, even though this is so simple, but many students, when they do this thing, they forgot to, when they want to put their sample on this thing, they forgot to close this thing. Okay, they forgot to close this thing, so it's end up all their sample goes out. When all your sample goes out, then you need to redo again. If let's say here at the beginning it's okay, but let's say this is like your third, fourth, 10th extraction, then is you need to start from the beginning all the way. Okay, so that's the important thing lah. If you see here, this is not a plastic, this is Teflon. Okay, the thing that on your what you call non-stick frying pan. So this Teflon, this very resistant to any chemical. So even though it looks like plastic, it's not plastic. So that's why we use this. Some of the separating funnel they use a glass. Okay. So this is using the Teflon. One of the what we call the good thing about Teflon is have very lubricating properties, so it's quite smooth. Rather than you use glass, is you have this sound creak like that. But Teflon is non-sticky, so that's why people put it on non-sticky frying pan, and also it's not reactive. So that's why people can cook food on that. Okay, now, so we put our sample here into this what we call the separating funnel. Okay, now you get that, you get that. Okay, your sample in the separating funnel. So let me move this thing and I put somewhere there. So I make this, I take it out that first, slowly, because you don't want to mess this thing. Okay, I put slowly there. Wait, it's quite difficult to do it, handle it alone. So here you can see there are retort stand. So you don't need to what we call hold with your hand like this. So you can put on retort stand. Okay. So basically, typically when you want to put this what we call this separating funnel, you use like the retort stand with the ring. Okay. So this is not the ring. This is more like the what we call the pincher here. But the best thing is to use, the easiest thing is to use the ring pincher, the ring what we call holder. But we don't have the ring here, so we use this thing. You can put his either like this, but make sure it will not slip down. Okay, when you close it, make sure it's not slip down. There are many cases that students they use this pincher type of the retort, and then they don't what we call they don't tighten it correctly, and then the whole thing, not only their sample spill, this glassware also broken lah. So, but I just rather do like this, much easier for you. Okay, and then we need to put something on. We need to put the flask. But before we put the flask, let's look now. So now we have our dichloromethane there. So now what we want to do? So let me put this, because dichloromethane is evaporating. So you need to close that. So to prevent that from evaporate to the atmosphere. So you need to close that. So now what we do? Previously we use oil and water, but now what we do? Any idea? What we do now? Question time, 1%. What we do now? How we want to extract? Okay, first we want to do extraction of an acid now. So inside this you have acid, base and neutral. Now we want to perform extraction of acid. We want to take the acid out. What is the thing that can take out the acid from this stuff?
Okay, sir. Can I?
Name?
Bakir Abdurrahman.
Okay.
We can put the aqueous solution base. Then we can put it with the base with the acid. Then that will make it soluble in the water. Then we can drain it down.
Okay, thank you. So that's correct. Okay. Okay, so now another question. Why? Why you put base, aqueous base here? Why you put aqueous base there? For example, let's say I put I make it here first. So if you look here, first here we will put isolation of the acid. So we put 10 ml of 5% of NaOH, sodium hydroxide. Now the question, why? Anyone? Why? We know we put the base here, but why? Anybody? 1%?
Can I?
Bakil again.
Yes.
Okay, so this is the last for Bakil because it's maximum 2.5%. So you already 3. So
Well, I will try. If maybe my answer is not correct,
yeah,
I will try.
Okay, Bakil.
Because there will be a reaction between the acid and the basic, and the electrons also will donate and will accept from the acid and the base. That's why we use this basic.
Yeah, that's correct. So basically what happening is that, if let's say I go back to this, let's say I go back to here. Okay, what happening is that if now you have acid, you know the acid is like this, you know this is acid. So this is your, because we have the benzoic acid, this is benzoic acid, benzoic acid. Okay, when you add the base NaOH, okay, what happened? This thing, the acid part will be deprotonated lah. So basically what will happen is that this will become CONA lah, CONA plus, and then you have this what we call the H2O lah, H2O. Yeah, I think it's correct, because this part is basically COOH. So your what we call this is the one will be changed into the Na lah. So this become Na instead of H, it will be deprotonated. So the H going out. So it will going that. See? Okay. So this thing we call it sodium benzoate. Okay. Sodium benzoate is basically soluble in water. Okay, sodium benzoate is basically salt, and this is soluble in water. Okay, so the second key point that you need to know is this main PC. So let's go to this, and then okay. Now the next key point that you need to understand is that this number 3, when you have organic acid, I mean the acid that we used just now, the benzoic acid. When you add with base, the neutralization happen, the reaction, chemical reaction happen. You get the organic acid salt. Okay, so organic acid we know that is insoluble in water, but it's soluble in DCM, which is your what we call organic solvent. You add with the aqueous base. What does it mean by aqueous base? The base is NaOH here that we use, NaOH. But remember, this NaOH, if you try to buy it, in what we call in the chemical store, it's just like a pellet. It's like a granule thing. So aqueous NaOH means that you add water into that granule to make the aqueous NaOH. Okay, it's like imagine it's like sugar. Sugar is a sugar, it's a solid. But then to make a sugar water, you need to add water. So now you have the aqueous sugar. Same like this, you have the aqueous base. And remember, previously our acid doesn't dissolve in water, but then when they have reaction with the base, it becomes sodium benzoate, and this sodium benzoate is soluble in water. That's why you will see there are two separation happen. So you get this organic acid salt, which is sodium benzoate, water soluble. Similarly, later on you will do this organic base plus aqueous acid, the same thing, but now it's base. Organic base, we have this p-chloroaniline inside our mixture. It is insoluble in water but soluble in dichloromethane. Okay, if you add aqueous acid, same idea, but now instead of deprotonated, this is deprotonated. Number 3 is deprotonation. This is protonation. So you add the hydrogen to the whatever this organic base, the alkali. So you get organic base salt, which is water soluble. The idea is same as this. So that's two key idea that you need to take note lah. So let's go back to there. So we done with that. Okay, so we done with that. Now we have this 5% sodium hydroxide. So this is what we call the aqueous base. You have the base inside the water. Okay, so we add this. So we take what we call where is the sodium hydroxide? We will add 10 ml of this into that. Okay, we take 10 ml this into this thing. Okay, we take this, and as usual we need to make sure you change this thing to the NaOH. So this NaOH, the one that I use NaOH, 10 ml. So you just pipette 10 ml there. So pipette 10 ml there, and then put there slowly but surely. Don't rush, because if you rush, thing happen. Even here the beaker, you need to what we call to label. You see here, they are label. Okay, make sure you label. So now we have this aqueous base we want to put inside this. So we take out like that, and then we just pour like this. As easy as that. Okay, now if you look here, if you look at this what we call separating funnel, they already have two layers. Okay, you have this aqueous layer at the top, aqueous base layer at the top, and our mixture DCM at the bottom. So now DCM is heavier than the aqueous because water, aqueous base in water. So that's why it's on top. So now here nothing happened. There are some reaction, but the reaction only occur at this what you call the interface.
Surface.
Okay, so now there are very less surface area. In order to bring all the acid from here, you need to shake this thing. So how to shake it? Just take it out, and just I bring here, put there, and then you just shake like this. Make sure you what we call, you put your thumb or whatever here, easy like this lah, like this, and then just shake like this. Shake vigorously. The idea of shaking vigorously is that you want to mix all this what we call all the acid inside the bottom layer to the aqueous base on the top layer. So here I will explain, but later on when we do the extraction for this thing, this other stuff, I will not explain. I just go straight away because to save time. But this is the first time we just shake. I explain while doing this. You shake, and while you shake, remember here inside this there are organic solvent. We have DCM, and I said DCM, being organic solvent, typically they have a lower boiling point, like ethanol. It evaporate faster than water. Similar to this DCM, it has lower boiling point. DCM boiling point is around 39, 40 Celsius like that, meaning that when you turn the heat to 40 Celsius, it's already boiled. Water need 100, right? And because of that, because of there are vapor already there, so they create like a partial vacuum here. They have like pressure here inside this. So you need to vent this out. There are pressure built up inside this chamber. So you need to vent it out. So how to vent it? This I will push this to let the gas coming out. So you will hear hiss sound. I don't know whether you can hear or not. here. Can you hear? Like that.
Yes, yes.
Yeah. So that's basically the gas coming out. So the reason is that we don't want the pressure build up lah. So we close again and then we shake like that. Shake, 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 shake. And then we vent and then we shake, shake, shake. This is basically what happening now is that extraction happening now. The reaction happening now between the one liquid with the another liquid, between the base and the acid inside the DCM. So we done that and then we put there. So you see it takes time. Okay, you can see, right? I don't know whether you can see. I want to what we call to zoom this, but let me check whether I can zoom or not. I don't know where it's moving. I don't know where is the thing. Where is my control? I don't know. But it's okay lah. I think you can see there. But it's okay. Anyway, it's okay. So now you have a two layers separating now. So now what if you look here, I cannot zoom lah. I don't know what happening, but anyway, I put here. So what happening now is that you see the aqueous base previously is like colorless, now is a little bit cloudy, meaning that some of the acid already going to here. So now we want to take it out. So in order to take out, we need to put something below that. So now we will put, so we know now bottom is our mixture, top is our acid. So here is very important to you to know which is to which. Okay, you need to know which one is which. So now the bottom is our mixture, so we use our flask before, the mixture flask. We have a label there, so we put there. But don't put like this, because if you put your glass flask here, the organic solvent will splash here and there. So you need to put something to prevent that. Where is it? So I put this. Let me put there. Yeah, like that. So then I think it's okay. Okay. So now I will open this. I will open this thing. But the problem now, if I open like this, at some time it doesn't, it have like bubbling there. You see the bubbling there? Okay, you see the bubbling? Can you see?
Yes, sir.
Okay. So question now, why? Why they are bubbling there? Give your name and answer that. Why they are bubbling there? What happened now? Why that's happened? My question is that when you open now, the bubbling happened, and then why that happened? Others then Bakir.
Sir, can I try to answer, sir?
Yeah. Name and
My name is Ali Fahimi, and what is my guess is how the bubble created is because the air from the bottom come into the flask, then it makes the bubble.
so what?
To make
So how to prevent that bubble from happening?
I think we open the knob at the separating flask slowly, I think, or open the upper close.
Okay. So because just
Meletup
now,
that,
okay, yeah, that's correct. So just now, opening the knob, I opening the knob very slowly, but still the bubble happen. The reason bubble happen is that now you need to understand that there are air here, so the air will put the pressure inside this. Okay, there are nothing to push from the top because they are close here. So the air, there are no air from the top to push this surface down. So that's why all air going inside here. So that's why the bubble happen. So in order to do this is that you open this thing. And the reason this is important is that many students, they forgot to open this. And having bubble is one thing, but the problem with having bubble is that you will not see the distinct separating line there. So you cannot really separate it. And also certain time you cannot nothing coming out because the pressure is quite big here. So sometimes when you open, if you close it, sometimes there are no liquid coming out anyway. Okay, so now we open, we do it slowly. I don't know you can see or not, but at least you can see lah. Okay, so you need to make sure you open it just enough. Make sure, and okay, like that. Okay, so you just take the lower half only. Okay, so now what inside this? Question time. Anybody? Why there are no sister here? It's always brothers. What is inside this? Very easy question. What is inside this? 1%. This is chance for you to get the marks. Huh? What is inside this? What inside this? This flask? Anybody? Nobody? What's now inside this flask? And what is inside this funnel? What inside this flask and what inside this funnel?
Sir,
Okay, name?
my name is Muhammad Afif.
Okay. What inside this flask?
I think it's H2O, water.
Sorry, again?
Water.
Water. And what inside this?
Sodium benzoate.
Sodium
Benzoate.
benzoate. Okay, it's okay. You still got marks because you answer. Okay, basically like this. Inside here, previously we put what we put our mixture inside that, and then we shake it, and then there are 2 layers. So when 2 layers happen, the acid from the DCM going to the top, going to the what we call aqueous base. At the bottom is still the acid is inside. At the bottom here you have the DCM, neutral, and also the what we call the base. Inside this you have this acid. So if you look here, because you need to clear about this first. If you look here, okay, let me open this. After this I just go fast, because this is just the idea only, the first idea. Okay. Okay, you look here. Imagine now this red triangle is acid, blue is a base, blue square is a base, and round green is a neutral. Now when you put inside the DCM, so DCM is the black thing here, so everything is inside this thing. You have the acid, you have the base, and you have the neutral. Acid is red, base is blue, and neutral is green. Now when you add 10 ml of this is sodium hydroxide. What happened? It will separate. The sodium hydroxide will capture the acid, because as I said before, the sodium hydroxide will react with the acid inside the DCM to create a benzoate salt. The benzoate salt is soluble in water. That's why the acid goes to the water here, goes to the base, aqueous base here. So that's the reason there. Okay. So now when you run the bottom one, what inside the bottom is this. You have the blue thing, green thing, and you have the some acid. Maybe some of the acid is not yet separated, because it's not separating using the liquid extraction is not an exact science. Sometimes you cannot get everything from one phase to another phase completely in one go. You need to do redo, because if you look here, there are some acid still left in the dichloromethane. So what you need to do is you need to repeat again this thing, repeat again this extraction. Okay, repeat again this extraction. So let's go back. Okay, so you repeat again this extraction. So now you have this DCM and also the neutral and also the base inside this. Here you have acid here. So now how to take out this thing? So you need to prepare another flask. Okay, you need to make sure you label your flask. This is very important, because during the real lab, I mean physical lab, many students make mistake here. They do all the extraction perfectly, but at the end they don't know which flask is which. Okay, so happen many times. So this acid flask, so you pour your acid inside this, but how to pour that? You cannot pour from the bottom. I mean, it's not recommended to pour, to open, to just take it out and then put this and then pour. Because why? Because if you do that, your acid now will contaminate with whatever coming out here lah. So the way how to pour it, so you take it out this, and then you pour from the top. That's much better lah. So that your acid in aqueous base doesn't mix with whatever inside the DCM. So now you have this. So you have two things now. So you have this. This is a mixture. You have DCM and also the base and also the neutral. Here you have the what we call the aqueous base, and you have the acid inside that. So this acid flask, this is a mixture flask. Okay. Now, as I said before, we need to repeat the extraction. Okay. So this is a mixture. This is the acid. If you want to repeat the extraction, which one you repeat? This one, the mixture one, or the acid? Question.
Mixture.
Okay, name.
Muhammad Afif.
Okay, which one you do the extraction? This one, the mixture one, or the acid flask?
Mixture one.
Okay, correct. Why there are no sister answering? You don't miss the point, huh? Okay, anyway, so you have the acid flask, you put aside, and then we just simply put inside this our original ni lah. It's the same thing, so it's okay. So we just pour it. Okay. So now we add another what we call another what? What we add now? What do we add? Question again. Now what do we add to extract leftover acid inside this DCM? Okay, anyone have answer 3 times? Maybe you can give the answer at least. Maybe you can give the chance to others lah. Okay. What we want to add here now? We want to take out the acid, leftover acid inside this, because maybe there are some acid. Most of the acid is already inside here, but maybe some of the acid still inside this DCM. So how to take out this leftover acid? Question.
Yes, sir.
Okay.
Name Aina Bashira. I think we need to add water
You add water. Why? Why you add water?
to repeat the liquid extraction so that there is acid will go separated.
Okay. Okay, you get mark lah. But it's not water. You add, because if you add water, water and acid doesn't do anything. Okay, if you add water inside this, because we want to take out the acid from this mixture. If you add water, we know that acid.
So can I try?
Yeah. Okay.
Daniel.
Okay. Name.
We add the sodium. Daniel.
Okay.
We add the sodium hydroxide again.
Okay, so you add the aqueous sodium hydroxide lah. Okay, so that's the idea, because when you add the aqueous sodium hydroxide, that reaction between the base, the sodium hydroxide, and the acid will cause the acid move from this DCM to that aqueous base lah. So you don't add water, because if you add water, nothing happen. It's just there. You need to add something that can react with the acid inside this DCM. So we have. So now we want to add sodium oxide. So we have this. So that's why it's important to prepare your thing, because if not, it's haywire here and there. So we want 5% NaOH. So this is 5% NaOH. So we just take, and don't forget when you want to use a pipette. Now this pipette I just use, it's NaOH. That's why you need to label also your pipette, because this tip is basically quite rare lah. Typically you see the tips like this, pipette tip like this. This is for 1 ml and below, and this is cheap. I mean, you can buy a lot and disposable, but this quite rare lah. So that's why better you use, and then you reuse again, and so on. That's why I label. If not, I just throw away. So I take this 10 ml also. Okay, so we put here. Oh, that's not good, but it's okay. Just roughly lah. Okay, so this is NaOH. Okay, so we add into here. What we do now is that basically repeating the extraction. Repeating the extraction. This is not an option. Typically, it's necessary. It's not an option, but typically a necessary. I will show you why it's necessary later on. But let me finish this first. Okay, we have learned this, and then we vent. Make sure when you vent it. When you are in the lab physically, you must vent it not toward your friend, away from your friend, and also away from you. Because sometimes this is what we call, you need to understand this is vapor. Vapor sometimes is toxic and so on. So you need away from you. So you just this, and then you vent, and then you this, you shake, and then you put, and then you wait. Okay, now question again. What is top? What is bottom? And what should I put here at the bottom here? The flask. 3 questions. 3 questions in one. 3 sub questions in one question. Because it's easy. What is in top? What is the bottom? And what flask should I put here? Okay. Anyone? What's on the top?
Sir, may I try?
Yeah. A name?
No, Shifa.
Rifa. Okay. What's at the top?
Okay, so the bottom one
Bottom one.
is the DCM plus base plus neutral,
Okay. On the top.
and then the top one is the acid.
Acid. And then
So
what
you
put
must
here?
place the DCM plus base plus neutral flask at the bottom of the separating funnel.
Correct. So we use this mixture flask. Mixture flask, that the original flask lah. I mean, because this original flask is okay. Okay. So we just put this, and we just take it out, this thing, and then we just run this thing out easily like that. Okay. So like that.
Sir, I have a question now.
Yes.
When do you stop exactly? Because you cannot differentiate. When do you stop?
Yeah, of course. It's a good question. I also don't know. I mean, no, you need to wash it in such a way that, I know, it's just, that's why you need to do repeating the extraction again and again, because even here, you need to stop so that you see the meniscus just pass through. There are no exact signs here, but you just need to make sure that the sharp line end here and you stop. Okay, because still, even if you stop too early, then they are left over there. But if you stop too late, then you need to understand this is like the volume here is very little. So if you late a little bit, then everything will go out, because it's pour very fast at here. Here is slow down and then fast. So that's why it's quite an art. That's why it's better if you come later on, if you come to the lab, you try experience by yourself. Because it's easy to say that, okay, stop when the meniscus be here. But in reality, when you try to do it, it's not that easy. You need to really handle it with care. Okay, so that's the question lah. So now this is the acid thing. So you put into acid flask. Okay. Okay, acid flask. So now what we got here? So we got the acid inside this. We got the acid flask. So the acid flask we put somewhere else. What time now? It's 10. 9:30. 8:30. 10. 10:30. I don't know when. It's like this lah. I don't know when it will end. But after 2 hours, if let's say some of you have like data problem, you can stop, you can go lah. But if you want to stay, you stay, because yeah, this thing you need to remember is 6 hours lab compressed. Okay, after 2 hours, now is 1 hour, because we start at 8:30, 8:45. So after 10:45, if some of you have a data problem or something very urgent to do, then you can go lah, because I don't know, maybe 2 hours, 3 hours, I don't know this thing. Because the longest part is this extraction part. Extraction part you need to do it carefully, because if you mess with the extraction part, you mess with other part. So that's why I need to do it step by step. Okay. So as I said, after 2 hours, 10:45, if any of you have a data problem, you can just left this meeting. But if you still not yet answer any question, please ask the question before that. Before that, and after 2 hours, 10:45. For those of you who want to stay, then stay, because I still need to do it step by step. I cannot just mix here and there, because the nature of this, you need to finish the separating liquid extraction first before you do distillation, before you do sublimation. Typically the distillation is fast, sublimation is fast. It's just this, the liquid extraction they takes quite a long time lah, because yeah, the idea behind that. So I hope it's clear for you lah. Okay, so now I want to show you what is the reason we do this double extraction. Double extraction. So now we have this acid flask. This acid flask we just put somewhere else. We have this mixture flask. This mixture flask we put somewhere else lah. So now we want to see the idea of why we do it again, twice or thrice. Sometimes people do it many times. Here you cannot really see because it's colorless. Now we want to try to put some color on that. So for that, let's say we have this. Let's say I have one thing. So let's say I use this. So this is iodine. This is gram color Lugols. Typically when you do gram staining later on, when to see whether the bacteria gram positive or negative, you will use this Lugols or iodine to do your staining. So this, inside this, they have iodine and also have something as they have PVP IOD. If you see here, I don't know whether you can see or not. They have mixture of iodine and something else. Okay. So we see something. So let's say we take water. Let me put something there. This is basically to show you what happened when you do double extraction. When you do double extraction, what happened? So I have this, and then I want to take this. I take some water. Take some water. This is water. Water. Let's say I put 10 ml water pipette here. So let's say I put 10 ml water inside this. 10 ml water. So I put 10 ml water. I do fast now. I run my speed now. I hope you got clear idea. And then I have this Lugol solution. It's brown in color. So I take maybe I put like 1 or 2 drop, 2 to 3 drop. So I put 1, 2, 3, 4, 5 lah, 5 drop. Okay, 1, 2, 3, 4, 5. So I put somewhere here. So I close this. So you see here, you can see here, this is basically a brown in color. Okay. Okay, so now be careful lah. This is what we use just now. So we can put it somewhere else. Sometimes people forget. Okay. Then they use the same thing, same funnel. So you need to prepare when you do this extraction in your lab later on during the final project. You need to make sure you have enough funnel lah. If not, you don't want to put another extraction to this, because this have anything. You need to wash this first. Go, let's say put somewhere here. So you have this what we call Lugol solution. Inside this Lugol solution, they have iodine and something else. We want to extract the iodine. Previously we see there are no color, but here I want to show you with the color so you can see clearly why we do double. Okay. So now we have this thing, the same thing, so I will not repeat the explanation. So basically we want to put our stuff here inside this, so we put, so I just start now doing fast. So we put this, and then we want to extract the iodine. Okay. So the iodine is soluble in water, but is more soluble in organic solvent. Okay. Iodine is soluble in water. I mean, not really soluble in water, but it is very soluble in organic solvent. So example of organic solvent that can capture this iodine is hexane. So where is hexane? Where is hexane? Okay, so here we have hexane. Okay, in the real life you need to do all this in the fume hood. Okay, so this hexane. So so this is Lugol, so don't mixture that. So we put somewhere. So we have hexane here. So we have a new flask hexane. So when you do your experiment, you cannot just do it. I mean, some students they tend to do it very fast. You do it fast when you know really well and you prepare very well. For example, like this, I already prepare my hexane and so on. It's okay. But some students, they do very fast, and then now they put the hexane here and then they put inside that, and that's quite not really clean lah. So you put hexane here. So I take hexane, and remember this just now is we used H2O previously, so we need to change that. Even that you need to, that's the reason. So hexane, where is hexane? Do I have hexane? Yeah, I have hexane. So hexane, so this is hexane. So basically we want to take hexane here, take 10 ml. Put 10 ml there. And then we put that, and then we put hexane there. And then we close. Don't forget, sometimes you can knock this thing, and yeah, careful. Okay, so now as I said, this hexane can capture the iodine inside that. So we will see, because now we have color. So I just put that, as usual, you know the idea. So now this hexane can capture the iodine. So now if you see, nothing happened. Okay, so even this and this, you have two stopcock. Which one? So this is stopcock that we used just now. So don't mix. Okay, so we take this, and then we take this. If you look here, nothing happened. Mana? Okay, if you look here, nothing happened. You have this hexane, you have this iodine, plus something else, and the hexane. Nothing happened. The white and the brown thing. So look what happened if I shake this. I shake this, you know the idea, and then you went, and then you shake this again, and then you went, and then you shake it again, and then you went, like that. Okay. In the lab report, you need to discuss why you do this, why you shake like that, and so on. So you see, it's okay. Okay, so you see what happened. Let them settle for a while. Okay, the iodine is basically purple in color. So you see just now you have yellow, brownish thing, and then now suddenly there are purple thing there. Can you see the purple there? Yeah, you can see the purple, right? Let it settle. But the idea here, I just want to show you later on why we do double. Why we do double. And also, I want to show you now visually what happened, what I mean by the capture. I mean, liquid-liquid extraction captures something else from the one phase to another phase. Now, the hexane here, they capture the, what we call the iodine inside this iodine mixture just now. So, the iodine is basically purple in color, so it goes to the hexane because the iodine itself have more preference to go to this hexane phase. So now you have purple, what you call? You see purple light. I think it's clear because I not control the zoom there, so I need to just bring this. So I hope you see the purple. Okay, so the purple. So now I want to for you to what we call to understand the reason why we do double. When you work with the colorless, you don't understand. You maybe not appreciate that, but when you do with this colorless thing, with something that is color, then you will appreciate. So now we need to have flask for putting this. This below is what? Okay. Okay. So this is a flask for aqueous portion because just now for the iodine we add this Lugol solution into the water, so we call it aqueous solution. But now, question now. What's at the bottom, what at the top? What is the bottom, what at the top? Question. Anyone? Name and give the answer. What's at the top and what's at the bottom? Anyone?
So may I try?
Okay, name.
Nazura.
Okay.
At the top would be iodine and hexane.
Okay.
At the bottom would be water.
Water and because if water it will be clear, but now they are like color like that.
Water would be iodine. That would not be.
Yeah, this. Okay, water and whatever in Lugo lah. So basically, so the bottom one is the aqueous, the top one is the hexane, the organic solvent one. Okay, so you just take this and then don't forget, oh, this lower. There are reasons, even though you think you can do this, but when you try to open it, it will splash here and there. So that's why better safe than never. So you add another one. Yeah, add another one. Luckily I have 3 now. Oh, lucky. Okay. Okay, so now I open this as usual. So I open. Okay. So Bakil, you asked before where to stop. So now you have a color. It's a little bit clear. So I don't know where to stop. So you see now. If you see here, if you see here, you don't stop here because it's too early to stop. You need to stop a little bit lower. Oh, wait. Careful. Relax. Okay. Doing this thing, you need to be patient. So you have this, and you have the whatever portion here, hexane portion. So I put here from the top, and remember from the top we pour it like this. You can see, Okay. So now you see how the color. You can see the color transfer. But now, what I want to tell you is that what happens when you do double? Okay, when you do double extraction, what happen when you do double extraction? Okay. So let's say we want to extract this again, because this is basically the thing that have some, what we call, some iodine inside this, and iodine is purple. For now, this color is like yellowish like that, and then when we do extraction again, what will happen? When we do this thing, we repeat again, what will happen? Question. Anyone? If let's say I put this again and I put hexane again, what will happen to this color? If I put this, let's say I put this inside this, so the color, yellow color at the bottom, and then I put hexane. Where is hexane? I put hexane. Where is hexane here? Where is hexane? Hexane here. So I put another hexane, 10 ml hexane. So where is hexane? Hexane. Okay. So now the question is still open. What will happen to that color, yellow color, if I put hexane on the top and then I mix them like before? The question is still open. What will happen?
If no one will answer, I will answer, and I don't want marks.
Yeah, okay. It's okay, good. What will happen, Bakil?
Okay, the yellow will be less yellow, and the purple will be more purple.
The purple will be more? Okay. The purple,
Yeah.
The purple is here. The purple is here. The purple is this. So
I mean, okay, we will get more purple to the the yellow will be less yellow, and we'll move a bit of the purple to the colorless one.
Yeah, that's correct. So what we do? Let me put this first. Let me relax. Be careful. So this thing. Oh, don't forget to close, and then bring here, and then you just do it fast. Remember, when you do FYP later on, final year project later on, I hope when your time to do your FYP, you are able to be in your lab. Now, FYP cannot be in the lab, but I hope during your time, the COVID already settled, that you can be in the lab. During that time, you need to do alone, meaning that there are no one to teach you. So during FYP project, you are alone and you need to know all this by yourself lah. So that's why whatever you learn throughout this year 1, year 2, year 3 is important for you. For that, you can prepare for your working environment or during your FYP and so on lah. So now if you look here, let me put here. Okay, so if you see there, the purple, some of the purple, and if you look, the purple color there is fainter than this. Where is this? Fainter than this, because the leftover is not much. I mean, the first extraction, they already capture a lot of iodine. So whatever happened in the second extraction is just few iodine inside. So that's why the color is less pale purple there. But if you see at the bottom here, it's much clearer than our yellow color just now, to show that multiple extraction, what we do just now, is important, because if you don't do multiple extraction, probably some of your stuff still inside the mixture. So that's the idea lah. So we just take it out this. So we're done with this. So this is aqueous solution. So we're done with this. So it's okay. We don't need this anyway. And then we put this inside this. Okay. So we done that. So we done with this. So we put somewhere else, and then we put somewhere else here. So we done with this. They are also different. Just now what I did is that I add 10 ml of hexane for the first extraction, and then later for the second extraction I add another 10 ml of hexane. So now total is 20, right? 20 ml. They are different when you do, for example, let's say I have this here. Okay. So let's say I put 10 ml plus 10 ml, 10 ml hexane. So this is what we do. This is what we do. 10 ml, okay, you can see. But this is different than when you put 20 ml hexane together. It will not be the same. There are two cases. What we do just now, we put 10 ml, and then we repeat again 10 ml. So total is 20 ml. But now let's say there are somebody else, they do 20 ml at the beginning. 20 ml at the beginning. What will happen is totally different. What will happen totally different. This thing gives more recovery. What we do just now, 10 ml, 10 ml, will be more recovery. In your, I think later on when you learn in year 3 or whatever, you will learn about separation process. You will learn in detail about this liquid extraction. There are some calculation there. There are some calculation involving this thing. How much this, and why 10 ml plus 10 ml is not the same as 20 ml, and so on. So just keep in that mind. Keep that in mind. Okay, so we done. So that's the idea. The reason why I show this, even though it's not in the plan, to give you some idea what actually will happen, what actually happening. Okay, so now you have the idea about liquid extraction. Now I can do it fast lah. On the liquid extraction, I will not. I not explain a tiny bit, so I do it fast. So now we look where we are now. Okay. So we done this part we done. We done this part. We already extract the acid flask. We know we have acid flask, and we do redo again, and so on. So we have acid flask set aside. So now we do the second one. So this we wait later lah, because we finish all the extraction first, liquid extraction first, and then we do all the stuff later on, because this stuff is quite fast lah. Okay. So now we extract the base. Extract the base. In the mixture flask, we have now whatever we left here. For example, here when we extract the acid here, we have acid flask, and we have another flask here. This flask will be used. You have the blue here, blue square, and the round green circle here. We want to extract now. We want to extract the blue. The blue is the base here. We want to extract the blue square here. So what we do, the same as acid. The same as acid. Now we want to what we call we want to add what's here. Okay, what we will add here? Question? Anyone?
Acid.
Okay, name?
Ame.
Okay.
Ame Hafiz.
Okay, what you put there?
Aqueous acid solution.
You put acid, Okay, when you put acid, acid will react with the base, and the base will go to the acid. Okay, so I run through this idea first, and then we go straight away lah later on. So you get acid, and then now the acid will capture the base. So the base will go into the acid phase lah, acid phase. So now, because this is a base, we put a base flask. This is base flask because there are base inside this. But here we call it aqueous acid extract. Okay, takes time to understand this. This is base flask, but then whatever inside this is aqueous acid extract. Okay. And now you have base flask here, and then you have this what we call whatever left over. So you have this what we call the neutral and also some leftover base. So that's why you repeat the extraction. We see before why the reason you repeat the extraction, and then you get this neutral flask, you get the base flask. So you done there actually. Okay. So now we do the experiment itself. Okay, let's wait for them. Okay. So now the idea for this, if the acid is like this, the base is mana madam? Okay, it's okay. So the acid, okay, we have base. Our base is what? Our base is this. Still you have benzene, and but you have this NH2, and then you have what? CH3, and then you plus with the base. Base, you add. This is base. This is base. You add with the acid. So acid is HCl. Okay, when you add this, what will happen is that this will be protonated. This is what we call protonation. Protonation. This is what we call, what will happen here is protonation. What does it mean by protonation? You know, acid is a substance that can give proton. Proton is basically the H plus like that. So that is proton. So now it will give this proton to this base lah. So what will happen now, you will get this, and then you now instead of that NH3 you get NH3 if I'm not mistaken lah. Okay, so and then you get the, is it correct? NH3, you get NH3 If I make mistake, please tell me because I also not really sure here. I think is it? Yeah, I think. Let me check first.
NH2Cl sir.
Cl Oh,
NH2Cl.
Yeah. NH3
plus Cl.
Oh yeah.
Plus Cl negative.
NH3 plus Cl
Cl negative.
Cl negative. Okay. Cl negative, and then you have H2O there lah. Whatever. So that's basically. So this is basically the.
And Cl at the bottom.
Huh?
Cl at the bottom instead of CH3, right?
At CH3
No, Cl downstairs or down.
So this here.
Yeah. No.
CH3 change to Cl.
CH3.
Change to Cl.
CH3.
Change to Cl.
Cl.
Yeah.
Yeah.
Okay.
Yeah.
Change to Cl. Let me check first. Also not really sure. Oh yes, it's true. So this is organic chemistry. So I think the detail for that maybe you can ask your. This is a theory, more to theory. So but the idea is this: if the protonation happen, this thing is a salt. So this is soluble in water. Soluble in water. So that's what will happen lah. I don't know whether this becomes Cl. I don't know whether this is correct or not because I'm not sure. I'm not sure because in order to attach Cl here, you need something else. I'm not really sure about this, even though in your lab manual say this, but really, if you ask me, I'm not sure about this. But what I'm sure that this thing happened lah. They have NH3 plus like that, and that's because of that. And this NH3 plus and Cl minus is this, and this is basically the salt lah, because you know NaCl is a salt. You know salt, right? So Na plus Cl minus. So that's happening here lah. But this I'm not really sure. You can check later on. It's quite confusing me. This I don't think it will change. Yeah, it's quite. Yeah, I don't think. You tell me later on. Okay, so enough for that. So this is organic chemistry lab, so not the class. So it's okay. Okay, now, okay, so we have a mixture here. Inside this mixture, we have this neutral and also the base. We want to extract the base from this, so I do it fast. So we have this, and we have the, we add what? We add the HCl, because the base we want to capture with the HCl. So we use 5% HCl, so this 5% HCl. So as usual, we have this pipette, and then with this pipette, because this is previously we don't use this, so we use something, this HCl, where is HCl, where is HCl? So this HCl, so this the what we call the tips, and then we take 10 ml again, and we put inside this. Okay, when you do fast like this, you need to be really careful, because if you put somehow you put the acid to the acid flask, something different happen. So that's why label is very, very crucial. Now I put this, just add 10 ml to this. I add 10 ml to this, 10 ml to this, and then relax. No, we will use this again. Okay. You can do like this. Actually, the best way, that's why when you do fast, this happening. The best way is that you put your sample here first, inside this thing first, and then you add HCl. But it doesn't matter. It doesn't matter, because later on, it doesn't really matter lah. Yeah, it's matter a little bit lah. Because the reason why it's matter a little bit, because there will be some acid here. Some acid, it's good also, I make mistake here. It's not a big mistake, but it's not a good mistake. Because if you pour inside this, now you have this some acid, aqueous acid here. Aqueous acid here. Okay, aqueous acid here. But it's okay, we will use another flask lah. We will not use this flask anymore, because in this flask you have acid, and also you have the DCM. Basically in this flask you have this two thing lah. Two thing. Here you see there are two thing like. So when you put your sample, you put acid straight away into this flask. Basically you have this oil and water condition here. So that's why later on we need to change this. Okay, so that's in front of you to show you that when you do rush, that's happen. It might be like, it may be correct, but it's not correct. Okay, but it's okay. As long as this is good, then it's fine. Okay, so this we need to put somewhere far away, so that we don't reuse again. And then this, as usual, we shake, and then we fan it, and then we shake, and then we fan it, and then we shake again, and then fan it. I think it's enough lah. Okay, so you got the idea. And then we need to put the flask. So the flask is because the flask you need to base flask lah, because now, okay, the question, where is the base? While I'm taking my extra flask. So this is extra flask. Where is the base inside here? Where is the base? Extra mixture. Where is the base? Question, where is the base
In
here?
the top side.
Name and
Ahmed Hafiz. In the top side.
in the top part. Okay, so here where this is the base. So when that is the base, that's correct. So when that is the base, you need to make sure you don't put the base beaker inside here, bottom. So here is a bottom is still like there are some mixture, basically a mixture of the base and some leftover base and also the neutral, because not all base going to top now. So let's put, okay, so okay, let's say put here. Okay, so this is basically the mixture flask. We don't use the the one that we make mistake just now. We do a new one. This is new one. So that's why when you do experiment, whether you do for live stream or you do real in the lab, you always need to prepare the backup. If anything happen, it will save your time, because let's say you have this, you want to wash this. If you wash this, you need to remember there are water there. You need to let it dry. It takes time, because if you use this while there are water, remember water and organic solvent doesn't bond well with each other. So yeah, that's a problem also. So you need to have a backup. Okay, so now enough talking. So let's do this, and then let's put that there. Okay, careful. Here better you don't talk lah. I found that most students talking when they do this thing. Because you need to really careful. It's like when you watch your melting point experiment previously, to see where is melting point, the previous live stream. So you don't talk when you do that, because there are times that where you can talk, there are times you need to really focus. Okay, so this mixture flask, and then now we put this in the base flask. Where is base flask? Base flask. Base flask. So this is base flask. Okay. Oh, don't do like this. Take like this, because there are something else here. So you need to take base like this. Okay, so we do that. Okay, so now you have base flask. Where is the thing? If I don't label, then so now luckily I label. So you have the mixture flask and the base flask. So base flask you put aside, and then you will do again for this. Okay, so this what we do, we put again. We don't make mistake putting our SCl inside this. We put straight this into there. Yeah. So we put that. Make sure this is close. Put that like that. And then, so this puts here, and then we have this acid. So where is acid? So we prepare the sample, prepare the thing, and then this acid. Now we take this, and this is still acid pipette tip, so it's okay. So we take this. Okay, we put there 10 ml, and then we put somewhere, and then we close it, so we don't mess it, and then we put on top of this. I mean, it's more fun if you can do in the lab, because here you watch like this, yeah, it's maybe boring. You can take your food or whatever while watching this, but when you do it in the lab, that's different. The time will seems fly very fast, but when you just watching like this, maybe you think, this is too long, but believe me, if you are in the lab, that's different. But anyway, so this, where is the thing? So this is the thing. So that's shake. Get out. Shake again. Take out. Shake again. Take out. Shake again. And then you do like this, and then you do like that, and then now. Okay, now question. What we do now? What we do now? Tell me what we do now. Anyone? One %. If you still not get the marks, please take the chance lah. Because after the live stream, then there are no marks.
Can I answer?
Okay, name.
Nur Farhana.
Okay.
Nordin.
Explain what you want to do now.
We're going to filter again, but we have to take out the stopper first.
Okay, how? Which one? Okay, take out the stopper first, and then I follow you now. And then what? What to do?
And we take a new beaker.
New beaker.
A new flask.
New flask. Name what name for that? If you want to put the name on the flask, what name you will put? So this is basically like a visual experiment. It's like you doing this, I follow you. You make mistake, I make mistake. So what flask? Okay, you want to take a new flask, but what you want to label on that flask? Because you need to remember, every flask you need to, what we call, label. If not, it will mess up. You see there are a lot of flasks here. Okay, new flask, what you put? What is inside this?
Neutral.
Neutral. So what you label?
Neutral flask.
Okay, so luckily I have this. Neutral flask, already put neutral flask. And then what?
And then we put under the
I put under this, and then what?
And then we separate it.
How?
We turn the knob.
Turn the knob slowly. When you do it slowly, wait. Okay, slowly. Careful. Slowly, careful. Okay. So we take it out, and then what happened to the that leftover? What we do this?
So we take it out from the top
Okay, to what flask?
into the acid with the leftover of the base.
Okay, so that is basically we put in the base flask lah, because basically we extract the base because just now we have true lah what you said just now. So we put in our base flask, just inside our base flask there are already some base lah, but so there are left our base going on the top. So now we put this, just top up lah, just top up there. Okay, so now we have three things. We have base flask, and if I take the acid flask here, the acid flask that we do previously, and then we have a neutral flask, and neutral I put in the middle lah. This is what? This is mixture nothing lah. So we just, okay, so we have these three things now. So now the question, what the question? Okay, the acid flask, what is in the what is this flask? This question, there are three questions. In what is in the acid flask, what is in the neutral flask, what is in the base flask? Okay, don't say acid, don't say neutral, just you need to say also acid in what, base in what, neutral in what, because this is, you know, previously we have like a powder, right? The acid I show you previously, the acid is like this, it's like this. They are powder inside whatever, they are powder inside this whatever lah. But now there are no powder here. They are like, you have acid in what, neutral in what, base in what. So anyone, one question each, 1% for this. In the acid flask, what inside this? You have acid and, just say your name and ni lah, if you can answer lah. Even if you answer wrong, then maybe get mark also. Just participation. Or anyone lah, in neutral flask, if you want to say what is in neutral flask, what in the base flask, tell me lah. Choose anyone. What is in neutral flask? You have a neutral compound with what? Base flask compound with what? And so on. No one? No one is okay, because okay, basically I just tell you lah, in acid flask is basically you have acid, but this acid is in a salt form, so it's an aqueous base extract lah. The neutral flask, we don't do anything, so this neutral flask still in the DCM. This base flask is a salt, it's a base compound plus with the acid, aqueous acid extract, aqueous acid lah. Okay, so that's the thing lah. So this you need to clear lah which one is which. So if you look here, if you look where is the my thing? So if you look here, okay, if you look here, now we are already done here. So we already done here this part, from this to this, and then from this extraction of base you have done here, and then we have done here. We not yet done here, but let's do this lah. So let's do for the neutral lah. So you have the acid, neutral and base. Okay, let's say about the neutral just now, the one that we just take just now. Let's say we take just now the neutral part. So now the question, what we put here? 10 ml of what? So you have this neutral, so you have this. So you have this neutral compound here. So what you put here? What you put here? So you have the neutral compound. I want to do again the extraction, but what you want to put here? 10 ml of what? You can check your manual if you want to mark here. What we want to put here? What is this? The what we call? What is this question mark here? By the way, now it's at 10:45. It's already 2 hours. So if let's say you have a data problem, you can go lah. But if you want to stay, you stay lah. I will do it until the end lah. Because anyway, I will post this on the what we call, on the YouTube anyway. But if you want to stay,
Sir.
better lah. Yes, name.
Ali Fahimi,
Okay. So what you put here?
water.
Water. So that's correct. But why? Ada question? Ada person? Why you put water there?
Okay.
Sorry? Anyone? So the reason why you put water here, because remember when you do the aqueous, when you put here in the neutral flask here, if you try to look carefully, I don't know whether you can see or not, but you cannot see. But there might be some water inside this, because previously we add the neutral in the side the DCM, we add what we call the aqueous acid. Aqueous acid, because aqueous acid meaning that the acid in water, so maybe some water is inside this. So that's why we put water here, so that we can extract that water, because water will go to the water. So that's the idea lah. It's like more like polishing lah. That's why we don't redo again. We do only once ni lah, one step only, because we assume that only a very little water inside this beaker. So we do that straight away. So now we take water. So this, so we have water here. So we have water. We take this and then we where is water? So this water pipette. So don't do straight away. Remember, don't make mistake. We put in the beaker. Okay. So sometimes when you want to do fast, oh wait, my camera is here. Okay. So this water pipette, and then I put here 10 ml, and then I put there, and I close, do, relax, and you put here, and then this you put into separating funnel. So now, because this funnel previously you have aqueous whatever, aqueous acid whatever, so maybe we want to use a new, what we call a new funnel lah. We done with this funnel, so we use a new one. So we use a new one. So basically the idea is simple. The idea is the same. So you take this, what we call this a neutral flask. Some water might be here. So you just pour here. Pour there. And then we take this S2O. So this is the water. So you just put this in order to extract some water. Maybe some water inside this. So we add that. Okay. So we add that. And then we close this thing. We take it out. And then we shake it, and then we do that, and then we shake it, and then we do that, and then we shake it. This got messy lah, because I do it fast. But basically, you get this. Okay, so now you get this. So now the question: which one at the top, which one at the bottom? What is in the top? What is at the bottom? So the question now. So now the question, so what is at the top, what is at the bottom? Those who don't have marks yet, please ni lah. At least if you ask 3 questions, if you answer 3 questions, basically you cover all lah. You already got full mark for that lah. So those who are not yet answer this, take the opportunity lah, because after this there are no bonus mark anymore. I mean, after this live stream, there are no more bonus mark from me. Okay, I don't think Dr. Raha will do bonus mark. So yeah. So what is on the top? What is at the bottom? Here you have this. On the top there are something, and the bottom there are something. What's in the top? What's the bottom? So basically, this we add the neutral flask, and then we add water inside that. So anyone?
May I try?
Okay, name?
Nazira.
Okay.
At the bottom will be DCM.
Okay, DCM and?
Neutral.
Okay, and the top?
Bottom will be water.
Liquid water. Okay, so that's correct. So now we put the DCM at the bottom. Where is the DCM? So now previously we are extracting something to the top, right? But now we are wanting whatever at the bottom. So that's why it's very important for you to know what is at the bottom, what is at the top lah. So here DCM is at the bottom because as I said, the DCM is heavier than water, the density. That's why the density is one of the things that's important. So if you look here, the one that I did before, the oil and water thingy, I left it for a few times. So you see there are, instead of 3 layer, you have 2 layer only. You have the DCM plus oil because DCM capture the oil. And then top is water. So you see that's the idea. So now we are extracting the oil from the top to the DCM. So now for this we put at the bottom, we put the neutral flask. So we have this neutral flask and then we open this and then, okay, so this careful, I will keep quiet now. Because if you mess this, then you mess everything lah. You don't get the neutral. Open slowly. Okay, stop. Okay, so now you have this acid neutral flask and then there is water flask. Where is water flask? That's water, neutral, water. So this is water flask. So basically this is water. So we put like this. Okay. So basically this, we don't need this lah. We don't need this. We don't need this because this is just like a water only, water something lah, water something only lah. But when you do liquid extraction, it's a good thing for you to don't throw anything yet. Just put in the beaker like this and just put something somewhere else because you don't know. Sometimes you don't know. Maybe this is when you do a real extraction later on during FYP whatever. Sometimes maybe if you discard this now, maybe you don't know this is the compound, your compound is inside this, not the other flask. So that's why the people often say that when you do liquid extraction, don't throw away until you finish, until you really get your compound. Just put it somewhere else and yeah, somewhere else. Okay, so now it's tired lah, but it's okay. You need to finish it anyway. Okay. Okay, so now you have this acid, you have a neutral and you have base flask. Okay. So now we have done what? Okay. So those of you who have a data problem, you can leave lah if you have data. But if you don't have problem and if you have nothing urgent now, please stay because yeah, then you don't need to re-watch again or whatever. Okay. So anyway, so now you're done with this. We done until here for the extraction of acid. We done here, and then extraction and acceleration of the base we done until here, and the extraction of the neutral is we done until here. Okay, so now we look at the acid first. We look at the acid back. So we finish the acid part now, because we have the acid flask now here. So we have the acid flask now. So we want to finish this. We want to finish the acid part now. So here we will learn about the precipitation. We will learn about recrystallization, but we focus more on the mixed solvent method, and that's it lah. Okay, so we finish this one. Okay, so we have acid flask. What we do, we precipitate because inside the flask there are solution only, right? There are solution only, so we want to take it out. So if we go here back, so we put this whatever we don't want somewhere far so that we don't make it. So now we have this acid flask. So this is basically acid flask. Inside this acid flask is just acid inside a solution, aqueous solution. But we want to take it out. We want to take it out. How we want to take it out from this? This is aqueous, whatever aqueous base, acid in aqueous base. We want to take out the acid out from this. Okay, we don't do the liquid extraction anymore because here you have a acid only, so no need to do liquid extraction anymore. But we want to take out the acid from this solution. How we do that? So if you now come to the another key point. Another key point. So let me change this thing to here. Let me change to here. Okay, let's see the key point, the further key point. Oh, wait for a minute. Okay, so we done until 4. So the key point number 5 and 6. Okay, key point number 5 and 6. If you have organic acid salt, that is what we have. This is water soluble. That is what in the acid flask just now. You have acid inside the water, whatever lah. And then if we add more acid, what will happen? It will be protonated lah. It will be the acid. When you add acid, you protonate this organic salt lah. You protonate this organic salt, you get the organic acid. Okay, you get organic acid. This is what we call precipitation. This is basically a reaction. So to show you, it's like this. Wait. Okay, to show you, now we have this acid. Let's say I terbalik. Oh, this. Okay. The idea for that is that we have this acid. So we have this acid. Oh, there are water there. We have this acid, but now we have acid salt. CO and A. I must prefer doing this. There are water there. So I must prefer draw like this. O and A. So this is basically sodium benzoate. This is what we call water soluble lah. So this is water soluble. Now you protonate, meaning that you add another acid, HCl. So what will happen when you do protonated? This is basically what happens is that this part, this Na plus will change to the H plus will substitute this thing lah. So you will get this CO and then OH. You get this again. You get this sodium pula. You get this benzoic acid again. Okay, because now you basically further acidify it. So this what we call because this is not water soluble in water. What happen when you do this thing is that the acid coming out, it will coming out from the solution just like that, just like a crystallization. But crystallization is other thing. Crystallization is physical thing. This is chemical reaction because the chemical reaction happening there. So that's the difference between recrystallization that you learned previously in salicylic acid recrystallization. That just a different solubility in hot and cold water. But here is different. Here is basically reaction happening. So we call it precipitation here. Precipitation because the acid, a solid, suddenly coming out from the solution because of the some chemical reaction here. Okay. So, you tired? I'm tired. Okay, so let's do. So this acid flask. So what we do now? Let me put here. Let me organize a little bit, so that I'm not mess up something else. So what we do now is that we want to add an acid, a strong acid, to this. Okay. So we add this 6 molar of acid to this because we want to protonate our acid. There are acid here, but we want to add another acid in order to make it protonated because the acid inside this is a salt, sodium benzoate. We need to change this into sodium benzoic acid again. So we need to return add acid so that it needs lah. But for this you need to have what we call, if you look here, here, if like me okay. Okay, if you look here, what we do in precipitation is basically we add more acid. Here, aqueous based extract, we add more acid here. And then, okay, question. You can find it in the manual. What pH here? Anyone? What is pH here? If you are still around lah. It's already 2 hours. What?
Sir,
Yes, Erica. Name.
pH 3, Erica.
Erica. pH 3, yeah. So
Yes.
this pH 3. So basically pH 3 is acidic. So now, we need to cool it in the ice bath. So I need to take the ice bath first. So while I'm taking that, just get the idea what is written there. I'm taking the ice in the next lab first. You can also what we call go and take your water or food. Yeah. So add water. Okay, I'm back. So let's change this thing to what we call to another scene. How to change that? Wait, where is the thing? So let's go here. So now let me clean this a little bit. It's quite hectic here. So let me clean here for a while. So this is what, this H2O not needed, this H2O not needed, this is pen not needed, this is pen. Okay, so now, so you have this ready. Yeah? So remember when you do the ice bath, make sure you have the ice here, but you add water. And the reason why I do like this will be evident later on. But now, let's do this first. Let's add the acid, just add how much we need to add, we add how much, 15 ml. So again, don't forget, sometimes people forget when they are tired. So this is H2, this is different. So we need to use the, what we call, the acid, that thing. Okay, so this is the acid. Okay, the acid, 6 molar. We have 2 acid. Previously we used 5% acid. Now we use 6 molar acid. There are 2 different things. That's why you have 2 different pipette tip. Because even though it's still an acid, still the same acid, HCl, hydrochloric acid, but then you need to understand the concentration is different. So you don't want to mix the pipette tips with one with another, because it will affect whoever use this acid later on. For example, this acid, the technician will put it on this film hood for the next lab, other lab, and so on. So if I mess this acid, then the other group or other section or other lab class will have a different, what we call, not get their result accurately lah. Anyway, so we want to acidify this acid flask. So I put on this thing so that you can see clearly. Now we add this 15 ml. So this 10 ml. So this 10 ml. So we add there, we add. Nothing happened. If I can make it bigger, let me zoom that. Okay, this I can zoom. Wait, wait for it. Let me zoom. Want to zoom? Can I zoom? Oh, but before that, let me put the all the acid first lah before I do all this thing. So because you don't want to mess. When you play with acid, you don't want to mess with this thing. So you change to 5 because 15 ml. 5. Okay, so we take another 5. And then we pour here. Okay, so now let me close this acid first. So we do one by one. We don't rush. This thing, as much as I want to rush, but I cannot. Because if not, it will mess everything. So let me zoom. This put there. So this I put here. Yeah, let me zoom. Okay. So if you see here, there are not much. There are some. Okay, so let me change this. Thing. Okay, so if you see there are some solid coming out. Okay, if you look there are something coming out there. So that is basically precipitate. But we don't. Precipitation is different than crystallization. Crystallization have their very beautiful structure and so on, very ordered. Precipitation is basically acid just coming out. Okay, so we don't want to wait for a nice needle or whatever. We just want to precipitate. Later on in separation process class, you will learn the difference between crystallization and precipitation. So now we have this what we call this ice. The reason why I do like this, we put water here so that it will reach the water there, and then this can hold this thing lah. So because you need to make sure, the reason why we put water is that if we have this alone, the what we call the ice alone here, it doesn't make a full contact with the glass. That's why if we put water, so it's basically increase the contact area between the glass surface and the ice with water. So that's why ice bus is the water. So that's why I put water a little bit lah.
Sir, just to clarify, before putting the acid, the flask was having aqueous solution of acid also, right? With solid base.
No, yeah, it's not. Okay, we go for here. So if you look here, this acid flask, what's inside the flask? Inside flask there are acid, but this acid is the salt. Okay, but this salt is soluble in this aqueous base extract, meaning that the solution itself is aqueous base because you add base at the beginning, right? To extract the acid, you add base here to extract the acid inside. But then inside here there are acid already, but that acid is a salt. But this salt is soluble in a water, okay? Because aqueous means water, so this salt is soluble. So that's why you don't see anything. Now you want to take it out. You want to make this acid appear again. So what you do, you acidify this thing. Basically, you add more acid. When you add more acid, more concentrated acid, this is 6 molar, 6 normal or 6 molar, is different than 5%. This is more concentrated lah, I think. So this, when you add more acid, what happens is that the thing, it will be it will, basically this lah, this happening lah.
Yeah, I mean which acid you have put, and is it aqueous acid or what?
It's different acid. This is okay. We have this. I zoom out first. We zoom out first. Okay, we have 2 acid here. We have this acid
to make the acidification.
Okay, wait.
Acidification.
Yeah, wait. Where is my acid? This is acid. Another acid is another. Okay. So we have this. We have 5% acid. You see, 5% acid. We have 5% acid. This is what we do during when we extract the base. Okay, because when we want to extract the base, we want to have the acid react with the base. So we use this 5% acid. But now we want to further acidify the acid flask, the acid inside the flask lah. So that we use a different acid. So this is 6 molar. 6 molar. So this is 5. This is 5. So this is 5. This is 6. This is more concentrated, I think lah. More concentrated. That's why, because we want to put it below to pH 3. So it's the same acid. Basically HCl, you can use the same acid actually to do this and to extract this and also to do this stuff. Same thing actually. It's just you need to add more of this lah, because both of them is HCl. The same acid, it's just different concentration. It's like you have very dark coffee and coffee. It's the same coffee, but the taste is different. If you want to get same taste as a very dark coffee, you need to, the taste is different lah kan. Concentration is different, but it's the same acid. The idea here, we use this concentrated acid to basically to reduce the what we call the pH, and when the pH reduce, the protonation happen. Okay, because when you do this, yes, we have the acid inside. We do have the acid inside here. We do have the acid inside. but then this acid is still a salt. In order to change this into benzoic acid, we need, in order to change, this color, this is not clear lah. In order to change this to benzoic acid again, we need to change this Na from aqueous base to the ash again. So how to provide the ash is from the HCl lah. So this concentrated HCl, so you protonate it. This is called protonation. So that's happened. So the O and A become OH now. So this benzoic acid, and as we learned before where we learn. Okay, so we learned before here. This is our original when we do at the beginning, when we add all our sample acid base neutral in the water. You see they are still not soluble, right? They are, yeah, I don't know you can see or not, but they are still there. So by right, the acid that we want to extract is not soluble in water. So what we do here is we want to bring back the solid out of the solution. That's the idea. So that's why we add acid lah. So I hope that's clarified lah. Okay, Bakir?
Okay, sir, but
So now,
later on. Yeah.
Yeah, so now if you look here, let me zoom there. Okay, let me zoom. Okay, so you see that is the, what we call, that is the acid, precipitate of acid. It's totally different than that lah. So now what we do is that, if you look here, we will finishing the acid part now. We want to do recrystallization. So we, for this, no, I will vacuum filtrate first. This I already set up the thing. So no, I think I just show you lah. I think no need lah to vacuum filtrate, because you have learned before, right? So this is what this. Wait. Basically, what we do now is we want to vacuum filtration this thing, but I think we will have learned this in the live stream number 1. So I think just show you this lah. So this is basically how it look when you yeah, can you see? Okay, right. The structure, there are no basically a structure like needle. It's just like that lah. So you can take this picture lah when you want to do this. Let me move myself, and now lah, it's quite hassle to move here and there. So I think I stay there on the top, because yeah, I don't want to mess with the setting. So basically that is the structure of when you precipitate. There are no definite structure, there are no order. The idea here, there are no order. When you crystallize, there are order. So this is basically when you vacuum filter the stuff lah. Vacuum filter this thing. So you see that inside this, they are, yeah, like that. Okay. Okay, we're done with that. So now, it's quite long today. It's okay. So now the last part for the acid is to recrystallize. So basically, previously we learned about recrystallization using the, let me put the ice bottom because I don't want to. Okay. So previously we learned about the recrystallization of salicylic acid, but now we want to perform the recrystallization using mixed solvent. Okay, mixed solvent. Let me open this first. Okay, so the single solvent here, we will use hexane. Previously, salicylic acid we use water. So now we use hexane. And also for the mixed solvent, we use methanol and water. The idea is this. Certain organic acid, they cannot recrystallize using a single solvent. Previously, we learned, okay, wait, let me put this. Previously, where's myself? Okay, previously we learned that you can recrystallize salicylic acid using the water alone. Okay, you can also recrystallize, where is my acid? You can also recrystallize this benzoic acid using the water, but also you can also recrystallize using the hexane. Okay, the structure will be a little bit different, and also you can also recrystallize using mixed solvent method. What I want to show is that mixed solvent method lah. Because sometimes you cannot use, there are some organic solvent that not dissolve in water, whether you heat it or cool it. Last time when we use salicylic acid, that salicylic acid doesn't dissolve in room temperature but dissolve when you heat. But there are compound that doesn't dissolve even if you heat it. So that's why you need to use a mixed solvent. The idea of mixed solvent, I think you can read along lah. So I just show you how to do that only. So we will not use this. Let me zoom out first. Okay, we will not use this acid. So I just prepare this acid so to save time rather than I scrap this. But basically this inside this, they are like benzoic acid. There are benzoic acid inside this. There are also benzoic acid inside this. So what we do, we do what we call the recrystallization using hexane here, and this using a mixed solvent. Okay, so now we start with this hexane first. Okay, so the idea here is that we want to add hexane here. It seems like the salicylic acid before. Instead of using water, now we use hexane. So now what we do, we take hexane. Where is hexane? Let me check where is hexane. Relax. Hexane. Okay, hexane. So CCl hexane there. So we add. Okay, when you want to recrystallize, like you learned before, you just put a very little only. Maybe I will put 4 milliliter only. You put hexane. Okay. Okay, so I put 4 ml. So I just put 4 ml hexane. So we take hexane. Where is hexane? Okay, we have hexane here, and then we open. We take this. We put this. We just put this, and then we put here. Okay. Because hexane is organic solvent, this acid will able to dissolve in this anyway. No, hexane. The acid does not really just soluble a little bit in hexane, not most of it. So you need to heat it. Okay, so let me put somewhere else, close this. So now another one, we will put the methanol here. So this what we do, the mixed solvent mixture. We add methanol here. So we just open this. Wait. Oh. Where is methanol? Where is methanol? This is methanol. So this is methanol. So this is methanol basically. So I give you the idea later on. So don't forget, change this. Hexane, methanol, and then 4 ml also. Wait, it's okay. Just a little bit. Oh, not close enough. Just a little bit. Anyway, yeah. Okay. So now we have this acid. Imagine now we have this. Imagine now we have this acid. We scrape it and we put inside the flask like this, and then we divide into two. So in one flask we put hexane. We put hexane inside that. Okay. So acid, our benzoic acid is not fully soluble in hexane. I think so. Yeah, it's not fully soluble in hexane. And also this methanol. This methanol. Our acid is fully soluble in methanol. Let me move it clearly. I repeat again. Our acid, our benzoic acid, does not fully soluble in hexane. Okay. So you need to heat this in order to make it soluble. In methanol, here this is methanol, acid in methanol. In methanol, it's soluble already. It's soluble already. Meaning that when it's soluble in room temperature, then how can you do recrystallization? Because the idea before is that when you want to do recrystallization, you need your sample not soluble at room temperature so that you can see it's coming out. But now it's already soluble at room temperature. This is okay lah. This is okay. This is what we do with the salicylic acid before. It's not soluble at room temperature, but when we heat it, it's soluble. And then when we cool back again, then it's coming out lah, recrystallized. But here is different. Here, it's already soluble at room temperature. Even though you heat it, it's soluble. When you cool it, it's soluble. So it's soluble at cold, at room temperature, and also at high temperature. So what we do with this? So that's why we use a mixed solvent technique. We add something that make our benzoic acid not soluble. We know this benzoic acid, our benzoic acid here, is not soluble in water. Here is a methanol. So if let's say we add water inside this, somehow the methanol will coming out. Not somehow, I mean that's the idea lah. So the methanol coming out, okay. So we add the water during this thing. So this is what we call mixed solvent extraction. So for this, let me bring the what we call the hot plate here. Let me put somewhere here. So let me there. So luckily I have a hot plate here. So you need to prepare. Hot plate there. So that's hot plate. So that is hot plate lah. So that's hot plate already. So basically this is hot plate here. So this I put somewhere else because we don't really want to use this anymore. Okay, so this hot plate we on this. So for the hexane here, this hexane which is not soluble there. So we want to make it soluble at elevated temperature. So we just put on this thing. Okay. Now about this mixed solvent extraction. So we want to add water here. Okay. So we want to add water here. So we just put that there. So I hope you can see both there. Okay. So now while they doing their job, let's look at what we want to do now. Let's look back to here. So yeah, we will not do vacuum filtration and wait whatever. This during in your lab report, please put the value lah. You put any value and then you discuss that value. Okay, your lab report based on this plan lah. Okay, while they are heating now, so now we are here. We are finishing the acid part. Okay, while they are finishing, because later on for this we need also the ice. So let me take the ice for those of you who are still around. So you can take your food or whatever for a while. Just let me take the ice. So I will come back later. So let me show this. Okay, let me take ice first. Anyway, if you have something urgent, you can go lah. Because I don't want to take your time. But if you have nothing, then just stay. I hope our acid already dissolved in hexane now. Let me check. Okay, I'm back here. So with this ice again. Okay, so now, okay, for the hexane it's already boiling. If you look here, it's already boiling there. It's already boiling. So it's dissolved. So the what we call somehow dissolved. So we just, this is acid in hexane. So we just put somewhere lah. Later I show you lah. So now what we interested this acid methanol water. Okay, so it's already dissolved. So now we add the hot water. So as usual, let me zoom out first. As usual, I will take the water. So I already heat some water over there. So I take this out. And then I take the water pipette. And then I take how much? I want to take around 5 ml or 4 or 5 ml like that. Okay. The idea why we do this is basically we know that our acid does not dissolve in water. So by doing this, we hope that our our acid inside the methanol will coming out. Typically when you do this, you will see that the solution will become cloudy. Okay, you maybe not see here, but there are some cloudiness lah. Okay, we maybe put like 10. Actually, when you do this, you do dropwise lah. Dropwise. That's okay. I have testing this before. Okay, let's say we do that. Okay. So now let's put this somewhere else. So now you have this. Actually, this is a little bit cloudy, but you cannot see, but it's okay. So basically, they are mixture methanol and water. So I put this somewhere else. I put somewhere else. So now we look what happens to the hexane. So you have this. This is methanol water. You see what happened to the hexane now. Let me zoom this thing. Because hexane evaporate very fast, so you can see the it's already give you the nice crystal there. Compare with the salicylic acid previously, when you use a salicylic acid, you use water. When you use water, when you use water, my phone battery is low. Okay, it's okay. When you use water, water takes time to evaporate to this thing. But in hexane, you see, it's just instantaneously it become crystal. So that's the difference. When you choose a correct solvent, it will give you different different outcome. Here, when you use hexane, you can also use water to do this. But water, when you use water, the crystal will become bigger, a little bit bigger lah. But here, when you use hexane evaporate faster, so you see it's already become a nice needle there. But if you look there, if you look this acid and methanol, nothing happened. Yeah, nothing happened. Nothing happened. So does it mean that our things wrong? It's not, because we need to leave it to the room temperature and then we put on the ice. Okay, so so I think we will not use this anymore. So I will close this. So wait for a minute. Let me check this thing. Oh, I have this. Oh, wait. I have this. Okay. So now what we do is that I just want to put our methanol mixed solvent thing here. So let's say I put water here in ice. Okay, if let's say I have done this before, this thing, if I left it like this on the room temperature, it will be stay like this, nothing coming out. Okay, nothing coming out. Because sometimes the recrystallization happen when when it's the temperature must be right. For this, you need to cool it even cooler. So that's why we put here. We put inside this ice, and then we just wait. Later, I put this to the side. Later, we come back to this. Just remember, later on we will see this. What happened to this? So I will put this somewhere else, and we will see the difference between hexane and also this methanol water mixed solvent method. So I just put this and also our hexane somewhere else, so that we know this. So later we will see that again. Okay, now we are done here. We are done with this thing. We're done with the acid. Oh, let me charge my phone. My phone is already. Wait, sorry. Let me charge my phone for a while. So now we're done with the recrystallization. Okay, now. Okay.
So may I ask a question?
Yeah.
For the precipitation of the acid, what if we use the stronger acid?
For what?
For the when we want to make the acid in the salt form to the organic acid, we use the acid, right? HCl.
Yeah.
What if you use the stronger acid?
Okay. It's still the same because it's a protonation lah. It's the same. I mean, it depends because HCl you have this H, right? NCl, the chlorine, whatever. So it doesn't really matter because acid, the term acid meaning that something proton. I mean proton donor. That is basically the concept of acid. Any acid is because from the acid we want just the H plus only. If you use nitric acid or hydrochloric acid or whatever acid is the same thing, but you need to remember is that acid have some reaction to, because sometimes if let's say you use hydrochloric acid, maybe that hydrochloric acid, okay, let me put here. For example, let's say you use the hydrochloric acid versus the nitric acid. Maybe the nitric acid will react with your sample and hydrochloric acid will not react with the sample. It's not just simply you want to use acid and you A and then you want to use acid B. It's not like more like option. It depends also, because if your sample react with that acid, then you need to use another acid lah. For example, you don't want that unwanted reaction, then you need to use a particular acid, because acid is basically the idea is the proton donor. Okay, it depends, but the idea is protonation. That's all. Okay. Okay, so now we done with this thing. We done with the. So we will see back later lah here. This part. So now we want to see we coming out. So where we left now? Okay. So here. So we done with the acid. So acid we done everything. So now we want to complete the base. Okay. Now we want to complete the base. So where we left now? So we have this, we have this base flask. We just did this base flask. Now, similarly, we want this base flask, inside this base flask is like a solution. We want to take out the base. So, question again, we want to get marks. What we put here in order to bring out the base? If acid, you put acid. If the base, you put, anyone, name? Easy now. If you still not get some mark, please take this opportunity. So what you want to put here? You want to extract base out of this aqueous acid extract. No one? If you put acid, you get acid. If you put base, if you want to take out acid from the acid aqueous solution, previously you put acid, but here what you put? Aqueous.
More base.
Your name?
Aina Bashir.
Aina. Okay, so Aina, so you put base lah. You put stronger base. Here you see 10%. We have used before 5% base here, but now we use a stronger base. So this the idea the same lah. Now here when we do that, for the acid here, when we need to cool in ice bath in order to see something happen. But here the reaction happen very fast, so you can see straight away the precipitation occur. So let's do that. Let's do that. Okay, so now we have base flask. So we have base flask here. So we zoom first. We zoom out first. Okay, so we have this base flask. You see, base flask is the solution there. It's just a solution. Inside the solution, there are base salt. So you want to take out this base. So you add further concentrated base in order to deprotonate this base inside this. So you take base. So let me take base thing first. Where is base? Base. Where is base? 10% NaOH. So now this is 10% NaOH. Let me. 10% NaOH. So this is 10% NaOH. I already put here. So basically you just add there. So you see straight away something will happen. So let me zoom a little bit. Okay, something straight away happened there. Okay, so I have this pipette. So I just take how much I want to put. I want to put 10 ml. So we change the pipette because previously you always need to what we call aware when you do this pipetting and so on, is the volume change and so on. Yeah. So we take 10 ml. So you see the reaction happen straight away. So you see there are nothing there. And then when I put base, straight away it become white. So now the base, which is the salt that is soluble in aqueous solution, now coming out. So it become white there. So you see there is whitish thing. Okay, so if you look there, they are white there. So they are white. So basically the base coming out already. So here, so the base already coming out. Wait. The focus is not there. Let me. Okay, so basically it's white lah. It's white. So now, so now where is this? So, okay, wait. I need to catch up my breath. Oh. Okay, so now we are here. So we are here. So we coming out. So the whitish thing is basically the base coming out. So now the problem now, our base is inside the water, aqueous, because when we add the concentrated base just now, it's still an aqueous. Now we want to put this back in a DCM. We know the base, our what we call, and the reason why this coming out, you see the whitish thing is because the base now is already insoluble in water. That's why you see the white, the precipitate, because the base is insoluble in water. As we see at the beginning of the live stream, the base is insoluble in water. But now we want to put this insoluble stuff inside this DCM. The reason why? The reason is because, let me check. Let me put this. The reason why we want to put this whitish stuff inside DCM, because here we have the base which is not soluble in water. We want to perform distillation later on, and we want to use the DCM lah, DCM for our distillate. We don't want to use water. But here actually you can just evaporate it. You can just evaporate this thing, and then it's already what we call, you get the base lah, because the base coming out from the water, right? So it's already separate. So if you left this on the bench and then you wait for a few days, you already get the white base, the original base lah. But the reason why we want to add DCM here, because we want to perform distillation, and our distillation we want to use the DCM as our solvent lah. So this we want to put back in the DCM. So the idea is same as liquid extraction. So if you look here, we will do some so I will do fast here lah. I will do fast. So I will do add DCM. So basically I will add DCM here. I put our whitish stuff inside this separating funnel, and then I will add DCM. When I add DCM, we know that the base have the preference to go to the organic solvent. So the base will go to the organic solvent, and then now we, as usual, we repeat again. We repeat, this is what we know, and then this just to polish lah, to add water, like the neutral stuff before, because the base flask here there may be some water lah. So we just do very fast here. So we will finish this until here. Okay, I will do it very fast now. So I hope you can remember what you see just now. So as usual, I will use a new one. So this is the old one. Okay, so I have a new one here. So let me zoom out this so that you can see in this thing. Okay, so we have this. We put here, and then we take this, and then we open this. Make sure this closed, and then we put here inside like that. So you see the white stuff there. So insolubility of the base inside the aqueous. So now what we do is that we want to add DCM. So we take DCM there, and then we remember that we need to change this thing. So this is what? This is NOH. So DCM. So we take DCM, and then we have the water. Where is the water? Where is the DCM punya ni? Mana DCM nya ni? Okay. So this DCM beaker, and then we open this DCM. We take this, and we make sure it's 10 ml because we want to put 10 ml. So we just take that, we put 10 ml there roughly, and then we have that, we close that because we don't want to knock this down, and then we add inside this, we just add there, and then 2 layer will happen. This 2 layer will occur, but now there's 2 layer, you need to mix them together. So this DCM put somewhere else, take this, take it out, and then here we just shake it, shake it, shake it, shake it, shake it, shake it, and then we vent, and then we shake it again, we shake it again, we vent, we shake it again, we vent. Okay, I think it's enough, and then we put that, and then we need to put what we call now we shake it again lah. We shake again. So give a good shake, and then shake like this, and then we put like this, and then we put a flask. So we have the flask. So now what is another flask? So this is new flask. So we have a new flask. Okay, so we put here, and then what we do is that we need to put something to hold this flask higher. So we put something there, and then we have this new flask, base flask. Don't forget to what we call to label. So we put here, and then we just open this stopcock, not stopcock, stopper, and then we slowly, I can't see, so slowly we take it out the bottom one. Okay, careful there, it's not that. So this thing, okay, so basically now you have this base inside this. Okay, so now that is basically the what we call what is that? That is the aqueous, the base inside the aqueous. So there are maybe some base there. So we need to what we call put inside back into the base flask. So this is our base flask original. This is our base flask that is already inside the CM. So this is a base flask that is in aqueous, the one that you see the whitish thing just now. So we just put again here, and now we do again double extraction. So what we do is that same thing, just put this, just put the stuff. Okay, so you're done with this, and then you do another DCM there because you want to repeat the extraction. So we have Dichloromethane again. So we open, and then we take this, we suck this thing, and then we put there, and then we put something there, and then we close it, and then we put there, yes, and then you put there, and then 2 layer happen again, but then you need to ensure you need to mix them together. So this put somewhere else, put far away, and then take this, and then this is, and then you shake it, and then you do this thing. In the lab, actually, students take a lot of time for this. That's why we need a 2 slot for the lab for this. The entire this thing, you need 2 lab, 2 sessions, 3 hours. Because in the lab, you need to understand, sometimes people make mistake here and there. I mean, the student, the first time they see it, okay, so this, you do again. Okay, so we put there again. Okay, sometimes we shake like this. Okay. So this is the last, okay, so you see that thing. Okay, so you see that thing. So now the base will go from the top one. Previously we see that are like cloudy, more cloudy than this. So you see the color now. So previously we have a very cloudy color, whitish color, the aqueous base inside this. But now most of the base coming to go to this DCM part. Okay, so we just take it out. So maybe we do another one extraction because this still cloudy. So in real life, how many you do extraction is depend. It depend on how much you want to do. So take it out this thing, and then I open this slowly. Okay, so take it out here, and then this put back into the base flask, put back into the base flask, and then we put here. Actually, the same thing. Actually, you don't need to put back. You just put the same thing. So, but I just use a routine lah. So easy. So that I don't forget anything. So you have this base again. So you put that. You want to put dichloromethane again. So take this and then take this 10 ml. So take 10 ml there and then put 10 ml there. And then you close this. You do triple extraction now because there are still whitish there. So maybe this is the last lah, the last. Okay, so we put that, and then as usual we need to shake it. So take it down. Shaking. Okay, so I think that's it for that. Okay, let them separate. So now I think most of the base, which initially the whitish part going to the DCM lah. So most of the whitish part now going to DCM is become paler and paler here. If you do it your research by yourself, you may want to do it triple, quadruple, or many time of extraction. But I think I stop here for 3 extraction only. That's good enough. So I have this base flask, so I just run this. Careful lah, this is base flask, yeah, because we have 2 base flasks. So this, take it out here, and take it out there. Okay, so now done. Okay, so done with that base flask. Okay, so you have this done. So let's close this. And then you see what you will do now. Okay, main PC. Okay, so now we done this thing. Repeat extraction. We even repeat for 3 times. So transfer to the base flask. So we have base flask now. So we do again. So we will not do this. This is basically water because I don't have another separating funnel anymore. But it's basically the idea here is same when you do previously for the the isolation of the neutral. You add water, you just want to extract some water inside this. So basically that's the best lah what you have to do. But we will not do this lah. We will not do this. We do straight here. Okay, we will do now. We will learn something new. We will add sodium sulfate here. Okay, we will show you what is that. Okay, we done here. We will not perform this, but in lab report maybe you can add this lah. The idea is the same as a neutral. So let's go to this thing. Silap. Here. Okay. So let's say now. Where is it? Camera. Okay. So now here. So here is basically your base flask lah. Now, inside this, they are based in DCM. They are organic base in DCM. Remember at the beginning of the story, beginning of the live stream, we mix everything in a DCM. We mix everything in DCM. We have acid, base, and neutral. But here now we have only base inside DCM. So how far is that? So now, inside this, because we don't do extraction with water, so maybe there are some water inside here. So we want to take out that water. Before we perform distillation. Okay, so now we continue. We will show you what is distillation. Okay, we will perform a distillation process. In order to perform distillation process, you need to make sure your sample is, for example, you want to distill the DCM only, you need your sample, because now you have the base and also the DCM. If you want to do distillation, you don't want water to mess around. So you want to remove the water first. Okay, so we will use this sodium disodium sulfate to remove water. Drying agent. This is what we call drying agent. You see drying agent here. So let's see what is drying agent look like. So basically it's just a powder there. It's a powder there. It's just a powder. And we want to use what we call the distillation apparatus. I will show you what is distillation apparatus. Let me set the camera first. Wait for a minute. Okay, because this I use a different camera, so I need to set up this first. Just like 10 seconds. Wait a minute. Okay, wait a minute. Okay. Okay, I think I set up the camera. Okay, let me coming back. So, if you look here, okay, that is the distillation apparatus. Okay, that is the distillation apparatus. Okay, in order to use this, if you look there, there are some what we call, there are some like a mantle there, like a hole. So we need to prepare. We put our sample inside this sort of like the mantle, the heating mantle there. So let coming back. So we want to put something inside this thing, round bottom flask. So we need to put this. We put there lah, easy. So we want to put our base and DCM inside this. But remember, inside this thing there might be some water. So we don't want that water mess with our distillation process. Okay. So what we do is that we want to take this, put here, because this is drying agent. This will capture the water. Okay, it's like your silica gel, whatever. But silica gel is the solid; they absorb the moisture. But this is what we call sodium. This is this. So this is sodium dihydrogen phosphate, anhydrous, no water. So basically, we use this to capture the water in a solution. Okay, put down. Okay, so what we do is that we want to take a spatula. Okay, the spatula. Okay, we take a spatula and then we just add a scoop into this. We add a scoop into this. Okay, we add the scoop of sodium sulfate, anhydrous sodium sulfate into our DCM plus base plus maybe some water. Okay, so we just add like that. And that's enough lah, I think. So we do like this. So we swirl it. Let me basically we zoom for a while. So let me zoom. So basically what we do is that we just to stick, and when you do this thing, you will see that the thing clump, the powder clump, the powder start to clump with each other, start to aggregate with each other. So let me add some more. The aggregation meaning that there are some water, that sodium sulfate already captures some water. So I want to add some more. I want to add some more. Okay. So the idea for this is to dry the solution. Normally you dry the solid, right? But this drying the solution. Drying here means that you capture the water out. So you just this thing, and then you want to put inside this, okay, inside this, okay, inside this, okay. You can just put, wait, you cannot see, okay. You want to put inside this. You can just put like this. Doesn't really matter because your what we call your drying agent settle down. But if you want to do like proper, you do what we call, where is the thing? Wait, okay, here. You just put inside this thing, the glass funnel. Let me zoom out. You put in glass funnel. The reason why we use glass funnel is because our sample is DCM. You don't want to use plastic. As I said before, the plastic will eat, the DCM will eat your plastic here. You see the plastic, they eat my plastic, or yeah, eat your plastic. So you use glass funnel, and then you want to do this. You can just do like this because you see that what we call, there are they are heavy. So the aggregate of sodium sulfate, if you can see here, I don't know whether you can see or not, the aggregate there is quite heavy, so it doesn't really matter now. But let's say you want to, let's say this thing, so you use, let's say you want to use filtration, so you use funnel and then you use this fluted, what we call fluid, this is what we call fluted filter paper lah. You learn, you can Google how to do this, but basically the idea is that to increase the surface area lah. When you have this, it's much easier lah. You just pour inside like that. Just pour inside like that. Just pour inside like that. Okay. Okay. So that is proper way lah. You can just pour like that, but this is more proper way lah. So what happening now is that it just dripping the thing inside this round bottom flask. This is what we call round bottom flask. Round bottom flask. Okay, so now let's go to our distillation part. So now let me show this thing, main PC, not main PC. Okay, so we see the distillation process. You have seen just now how distillation looks like. Okay, now inside this, when you hit something, you need to put. So here, let's look here first. You have first you weight the thing, you add boiling chip, and then add sample, blah 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 blah. So this distillation. So let's go back. So now you have done this. Now, if you try to hit this thing, if you try to hit this DCM with the base, sometimes when you hit something, the solution becomes superheated. What does it mean by superheated? Is that the solution become hot, but it's not boiling. It's like when you put your water, your distilled water, inside a microwave. Sometimes if your water is very pure and your what we call your glass is very clean, your water might not boil at 100 Celsius. That's what we call a superheated water, and that's very dangerous because if let's say you add something, let's say take sugar, put on the water, it will explode. Don't try that at home. So the reason why it's not boiling because there are no point, there are no site to boil. So the reason why we put boiling agent inside this is to prevent our DCM become superheated. Superheated here meaning that our DCM have a boiling point of 40 Celsius, 39 or 40 Celsius lah. Sometimes at 40 Celsius, if this is very clean, very new flask, you will see there are no boiling happen. And when there are no boiling happen at 40 Celsius for DCM, which is past its own boiling point, it is superheated. So when you add something, it will explode. So be careful about that. So that's why we add what we call the boiling chips. Okay, boiling chip. What is boiling chips? So this is boiling chips. So this is basically boiling chip. I don't know whether you can see. I hope you can see. You can see. So this is, yeah, this. I hope you can see lah. They call also anti-bumping granules. This is also another name for boiling chips. Anti-bumping. You prevent the bumping. The bumping. So the granule is like a ceramic. It's like a little granule that have a pores. So when you have the pores, it will promote the boiling. So it prevent your sample from become superheated. So we just put it inside this. So because just now we use the sodium sulfate, so we need to use different spatula. So please remember that when you want to scoop new stuff, new solvent, new chemical, you need to use a different spatula, or you wash this and do that thing. But I'm lazy, so I just use a new spatula there. So I just add some boiling chips. The reason is that we want to prevent the superheating from occur. Okay, now by right you should weight this thing. You should weight this thing because you want to minus the boiling chips. Okay, in your report maybe you can say okay, I weight this boiling chip is what, this thing is what, the flask is what, because at the end of the day you need to measure the weight of this thing lah. So now let's go to the distillation part. So we will finish the distillation part, and after distillation part is sublimation. Sublimation is very fast, so I think maybe around like maybe 10 more minutes, then we will end this lah. Okay, so thank you for those who are still staying. I know it's quite long. I'm also like but what to do, we need to finish what we start. So this, I will change the camera to this another feed. So that is basically let me check first. Let me take my phone so that I can see you there. Let me check first. Let me put my camera there. Okay, I'm here. Okay. Okay, so now let me change this thing. Wait. Okay. Hey, kenapa tak ni? Okay, this is what we call heating mantle lah, heating mantle. So we put our what we call our round bottom flask inside this, and this is what we call a condenser. This is condenser, this is heating mantle, this is round bottom flask, and this is three-way adapter. So the purpose for this is that we want to put here like this. We put here like that, and then we connect here. We connect here. We connect like that. We connect like that, and then typically we use grease in order to make sure it's sealed, because we want, the idea of distillation is that you want the DCM to vaporize. You heat the DCM will vaporize here, and then goes here, and then here we will run with the cold water, so it will condense, so goes down and goes down lah. So now in order to do that, you need to seal this. Typically we use the grease to seal, but I'm lazy, so I'm just use this cat clip. Some people said don't use this in order to do this, but because we know our DCM boil at 40 Celsius, so less than 100 Celsius, so that's safe lah. So we just put, so if you look this cat clip, they have this big and there are small macam mana? Yeah, you can see lah. So the big one and the small one. So the big one, if you see here, they are groove here. They are groove here. They are groove here. Let me whether you guys see or not. Let me zoom. Wait, I'm sorry, I'm alone, so it's very difficult to hold this thing. So you see, they are groove here. So you put the big one to the groove. So you see, they are big. Where they are big. They are big. The bottom big. The top is small. So here you have this groove, the big groove. So you put like this. So the idea for the cat clip is just like a clipper lah. It's just clipper. Okay. And we put also here. We put also here. So you better use this, what we call the grease only. But yeah. And also here, if you look here, let me move the. Okay. So if you look here, my camera. Whatever. So if you look here, they are like what we call. So we have this. Now let me zoom out lah. Zoom out. Okay. So we can put like this. Okay. We can put this like distillate outlet lah. So we also we put the cat clips, KECK clip. Okay. So we put there. Okay, like that. Okay. So now this you will put you can see or not? No, you cannot see. Wait me. Okay. So here there are outlet. So we put our beaker there. So don't put petri dish or whatever, because remember in our round bottom flask over there, that is basically DCM. So DCM is not good with plastic lah. So we put our sample like this. Okay. So like that. Okay, so now if you look back, let me zoom out. Can I zoom out? Yeah. So So this is sealed, and also this is sealed. So left over with this. So we need to seal this also. So how to do that is that we take the thermometer. So this is thermometer. Thermometer, you take this. So you put this what we call this groove there. So this no need to do this lah. So basically this, if you want to see your what we call the temperature while it's boiling lah, because you need to make sure you don't want to overheat your sample. Okay. Let me adjust a little bit here. Okay. So now, what we do, I explain the idea about this distillation first. Okay, let me move here first because it's difficult for me to work alone like this. Okay, so over there is basically heating mantle. Here is a three-way adapter. Your sample is inside this round bottom flask. Here is your thermometer to read the temperature when you boil. Because if you don't read the temperature, if you overheat your sample might be what we call, might be burn, or your what you call DCM might be explode or whatever lah. So this is what we call condenser. If you see here, there are what we call, there are two outlets, this up and bottom here. So this condenser, the idea for condenser is you want to condense the vapor. Okay, when you heat something here, the DCM will produce a vapor. When DCM boil, it will produce a vapor. So it will what we call going up here, and then going here, the vapor going here, and then when it meet the vapor meet the cold what we call cold liquid, it will condense, it turn back into liquid, and then it goes down, and then you will see the liquid coming back here lah, coming back here. So you will see that your DCM will be here, your sample will be left there. That is distillation, separating the sample, separating what we call your two things based on the boiling point. So here the boiling point for the DCM is 40 Celsius. The boiling point for our what we call our base here, because we have base inside that, is more than 100. So the gap between two boiling point is so high. So you can use this lah. If let's say we have the water inside this, so you know that water will boil at 100, so it will mess up with this all the setup. That's why we remove the water using the anhydrous sodium sulfate before. So here inside this is only what we call only DCM and base only. Okay. So now we need to run the water. Okay. So if you look here, you what we call, you link the water from the bottom to the top. From the bottom to the top. Oi, jangan gerak. From the bottom to the top. There are reasons for that. Because if you run from the top to the bottom, there will be air pocket here. Air pocket here. What I mean by that, if let's say I open the water here, the water will actually move around this jacket lah. This is like a jacket here. So I run the water, I open the water. So basically now, so you see there are water there. If you see, let me move, let me zoom there. The water tak? Oh, dah ada. So you see there are no air pocket there. If let's say I open, okay, yeah, I open the water. Okay, so I already run the water there. If you look here, there are no air pocket there. There are no like bubble or whatever. That's what happens when you put the water from bottom and water coming up there and going out here. If let's say you flow the water from here to the bottom, then there will be like air pocket, like what we call the air pocket lah. So that will cause this distillation unit heat transfer is not consistent lah. So that's why people flow the water from the bottom goes to the top. So that's why you don't live with some air pocket. So now we on this thing. Okay, we on this thing. So it's on ke? Yeah, on. So you see that on that thing lah. So because DCM is will boil at only 40 Celsius, so it's very fast lah. So let me check this first. So you will see the thing is boiling. Let me put carefully. Okay. So let me increase the. You can see top. So going up again, up. Okay. Okay, now if you look there, yeah. Wait, I will go near. Let me check there. Okay. So basically here now, the idea is that your sample inside this will be heated. So this is basically it will hit this thing lah. It will hit this mantle. The mantle will be heated, and likewise your sample will be heated inside. And then when it's heated, your sample, your DCM at 40 Celsius, it will vaporize. So when it's vaporized here, it will reach it will reach the bulb of this thermometer, and then you see the rise of the reading here lah. Okay, so the vapor now goes here, coming here, and then we meet the cool substance, and then it will condense going that until here. Later on, you will see a drip of DCM. You don't see. So it's okay. So now we wait this to boiling. So it will take a long time, just a few time lah. So here is basically the reading lah. I don't think you can see anyway. So yeah, I don't know whether you can see, but basically now is 40. Wait for it. Where is now? Yeah. So now it's 30 something like that. I don't know it's clear or not because I just zoom like this. I hope it's clear. It's pretty difficult to get this because the focus, I cannot manually focus by this. But roughly you can say it will rise to the 40 like that, and then when it's rise now is let me check. Now it's 30. So now it's here is 35. So you will see it's very few minutes now it will reach the 40 lah. So that reach the 40. So here that's the best I can zoom lah. Okay, so now it's reached the 40, and then I will show you what happened inside this thing. So now done with that. So now it's already 40 like that. So I will show you what happened there. So it's boiling. Okay, so the boiling stone that you use had to promote the boiling. If not, maybe your DCM still not boiling at this point. Okay, maybe your DCM still not boiling at this point. That's why we put the boiling stone there. So it's boiled. So now the vapor will go up there. So that's why you have this thing. And if you look there, the vapor will move here, go condense there. And if you look there, you will see difficult sungguh. Macam mana nak control ni? Okay, you will see there they are yeah. Okay, nice. Okay, let me go down lah. So basically now this is okay. Last question. Anyone, if you have any marks, 1% mark, what is this? If anyone still around lah. So what is this? What inside this? If anyone still around, if you want to answer this, you can get 1 marks like that, 1% marks. Okay, so inside this is basically the what we call the DCM, the pure DCM now, because we know the DCM evaporate from this what we call round bottom flask coming to this what we call let me zoom out. Okay, so the DCM coming from here and then goes down here and then coming out from here. And to know when it will stop, to know when is our what we call our distillation will finish, is that we want to see this. If there are no droplet occur, then your distillation finish lah. So that's the idea. When there are no droplets coming out, then you know that your distillation finished. Okay, so that's basically the idea of distillation. So at the end of the day, inside that thing, inside that what we call, inside this, you will left with only the base. You will left with the base. Now there are some DCM boil. So when you finish the distillation, this, you will end up only the base inside this thing, and your what we call your DCM will be in the other side lah. So you have two things now. You have the DCM, the pure DCM, and you have your base inside this. So that's the idea for the distillation. So we basically finished the distillation. So we will go to the last part, which is the sublimation. This is very quick. So this is pretty quick. I hope this is okay lah for this, for the distillation part. So let me change the what we call the camera to my main camera there. So let me change the camera to this thing. Okay, so we're done with the distillation. So we will finish it with the what we call the sublimation. So let me close it in. Okay, so we're done with the distillation. That's the idea of distillation. By right, you need to find the melting point and so on, but we will not do this because we have done the live stream for that. So we're done with the distillation. So the idea of this distillation is separation based on the boiling point. If the gap is very high, then you can use a distillation. Now we use the sublimation. So this is sublimation, the last part. So neutral flask, you evaporate and then you sublimate. Okay, neutral flask, you evaporate and then you sublimate, and that's it lah. So now let's go to this. Okay, so now neutral flask. Where is neutral flask? So you have this neutral flask. Where is neutral flask? So you have this neutral flask here. So, okay, inside this, your DCM, because previously you have a DCM inside this neutral flask, but now because DCM, you see just now the distillation, the boiling point for the DCM, which is a methyl chloride or dichloromethane, is around 40. So at room temperature, it's already evaporate. So you see there are some like left over there. I don't know whether you can see or not, but basically they are already there are no more DCM because it's already evaporate. Evaporate. So now we want to evaporate it further. So we will not wait for that because I have done for you. So now we have this. So this what happened when you evaporate. So let me put the black pepper there so that you can see clearly. So you see now, after you evaporate for 1 day, let's say you left this neutral flask on the bench for 1 day, what will happen is this. You will see, you will see this. Let me zoom this thing. Let me zoom this. Okay. Let me zoom again. Zoom. Wait. So if you see there are like a crystal there. So this is basically the camphor, the neutral, because the neutral from the camphor. So after evaporate, this will turn to this. This will turn to this. Okay. So basically this evaporates. So now you have a solid, and we will learn about sublimation. Sublimation is basically the conversion of the solid to the gas without the melting point, without the melting phase, without the become liquid. So we will try for this. So now let's do that thing. So it's pretty easy. For this is pretty straightforward, because if you look here, let me zoom out first, and if you look here, what we do is that we have our beaker, and then we heat that. We just heat that, and then we put what we call a test tube. Inside the test tube, we put the ice. The reason why we put the ice is because we want to make sure the outer surface is cool. And now when we heat this, what we call the neutral thing, our neutral is a camphor, it will vaporize, because the camphor here will sublime. It will not go to the water phase. It will not go to the liquid phase. It goes straight away to the vapor. So when you heat, suddenly you will see that this solid become vapor. It turn to vapor, and when the vapor meet this cold surface, it will be deposit on that. So it's sublimation in reverse. Okay, so we will see that is basically the idea is that you want to transfer the solid here on the surface of this what we call the tube. So let's do that. So this is the last part. This is the last part for this. Okay, to do that we need what? We need the heating mantle again. So we have this heating mantle. So there is heating mantle. Not heating mantle, heating magnetic hot plate lah, hot plate. So basically we had hot plate. So we done with this. We just put somewhere else. Okay, so we put on top of this, and then we heat it. Okay, we just heat that thing. So basically I turn the heat. Okay, so now we remove that first. So now we want to bring it up. We prepare first, bring it up, and then we do that thing. Okay, so basically now I'm heating. So this is a heating plate. So I'm heating now. So but we need to have what we call this test tube filled with the ice. Filled with the ice. So we will take the ice and then we put there. Okay, so let me take the ice for a while. Oh, I have. Oh, yeah. So I will take the ice in the next lab while waiting for that neutral to sublime. Okay, I'm back. So basically this is the ice, you know the ice, and now what we do is we want to put the ice inside this, what we call the test tube, normal test tube. So I just put the ice there, nothing fancy, just put the ice. Just put the ice. The idea is that to provide the cold surface outside, so that our vapor can sublime back, can deposit back into this surface. Okay. Okay. So we just want, okay, for example here, we just want the ice to provide the cold surface on the outer here. We don't want condensation here. That's why we clean this thing. We clean this thing. We clean this thing. So we just want the cold surface. We don't want the condensation. We don't want water outside there. Okay. Okay. Okay, so now we have a cold surface here, and then I put inside that. Okay. So that is basically the last part. So you will see now, I mean, I don't know whether, let me make, oh, careful, careful. Wait, I need to put it somewhere. So if you can see, I don't know whether you can see or not, but let me check that. If you can see, there are vapor everywhere there. There are vapor everywhere. The camphor vapor, the solid, which is the what we call the camphor, turn into the gas straight away. There are no liquid phase. So the gas will go to this cold surface and deposit there. Okay. So we wait for a while, but while waiting, let's look at what happened to our mixed solvent recrystallization before. Because previously we do a mixed solvent recrystallization and also recrystallization of acid using hexane. So I left it for a while. So now let's see while waiting for this. Okay, what happened to our acid when you do first in hexane versus when you do the mixed solvent recrystallization. Let's take that. Okay. Okay, it's finishing. It's finishing. What is the thing? Okay. Okay, now let me zoom that thing so that you can see. Let me remove this condensation first. Okay. Okay, let me zoom first. We are at the end of our session. Okay, so if you look before our, what you call? Okay, so this is what happened when you mix. See, this is what happened. Wait, I need to zoom carefully. Okay, this is what happened when you mix, when you use a single solvent of hexane to recrystallize your benzoic acid. Okay, so you see a small needle, a very beautiful needle there lah. I'm not sure whether, I hope it's clear there. But this is what happened when you use a mixed solvent method. There's a lot of condensation. Let me remove the condensation there. So there are a lot of condensation because we put this in ice bath just now. But anyway, I hope you can see they are. Yeah, I think you can see from the side lah. I don't know if you can see it or not. Yeah, there are some. So you see there are something coming out. So that is recrystallization. So meaning that you can use this method, either use a single solvent for benzoic acid or use a mixture solvent method. Sometimes for benzoic acid is okay, salicylic acid is okay because both of them can dissolve in water at high temperature. But then there are some compound that you cannot dissolve at high temperature, meaning that you need to use mixed solvent technique in order to perform the recrystallization. Recrystallization is basically a purification method. So I hope you can read further on mixed solvent recrystallization in order to get the idea what make this different than this. Okay, so now we are coming to the end. So we see what happened to this stuff. So we will see what happened to that stuff. Okay, what is this? Oh, this. Okay, so let me check. So if you look here, you see there are no more. If you can see, I mean, this is white. This is white. You cannot really see, but if you can see, basically at the beginning they are what we call residual camphor or natural compound that evaporated left over there on the base, but now it's disappear. It's already disappear. It's like when you put a camphor ball. It's same when you put a camphor ball like this. Oh, this is, I zoom out lah. It's same when you put this camphor ball into your wet robe, and then you coming back like a week later, you see it's disappear. It's same idea like this. Now, if I can just put this camphor ball inside that also work. Okay, because this is the same thing. This camphor, that's also the natural part, the camphor. So you put that, you heat, is what we call it's disappear. It have a for me it's a fragrant smell lah, because it's a smell of minyak cat kapak. So that is smell for this. So you can smell this thing now actually. So minyak cat kapak. Okay. So now you see that what happening now is that the vapor goes up there, meet the cold surface, and then if we take it out, if we take this out, okay, let me zoom first. This is the last. We at the end of our stream. I don't know whether you can see or not. Let me check. Let me check first whether you can see or not here. Let me check first. I put, wait. Okay, if you see here, where is the thing? Where is the thing? Yeah. I put bawah lah. Tak nampak juga. Okay, basically they are like deposit on the surface of this flask. If I can take that thing, if I just take that, you will see they are like, this is camphor. and yeah, it's quite nice. I mean, that camphor is okay. It's not dangerous. It's not really dangerous. People use it for the medicinal purpose, so don't worry about that. So you see, they are like, you basically transferring. So I put somewhere lah. So we're done with that. So basically, you transferring what you do just now is basically transferring the camphor at the bottom down. Previously, there are something at the bottom right. Now you transfer it magically. You transfer to the surface of the cold test tube, and I scrap it, and then you can get this. So this is basically the neutral compound that you extract lah. So that's basically the sublimation, the process where the solid turn into gas without without going to the liquid phase. So that is basically, if you look back to this, that is basically it's lah for the entire experiment today. So remember this, how long we take? 8:38, 4 hours. Yeah, 4 hours. Wow. But remember, this is 2 weeks session actually. 3 hours, 3 hours. Yeah, so that's, we cover everything. We learn most of the important thing. We learn about this liquid extraction, precipitation, recrystallization, distillation, sublimation, drying agent, and boiling stone. We cover all that, and then okay, here you can just copy and paste this thing. So I put now for a while. You can copy and paste, not copy and paste, mean that you can copy and use it for your reference. And we go back to our key point. So we miss a few things. So we're done with this. Most organic compound don't dissolve in water, but able to dissolve in organic solvent. Dichloromethane is denser than water. Blah blah blah. Number 3, number 4, you have learned that. Number 5 and number 6, you also have learned this thing. And number 7 and 8, I am not covered yet, but basically we have covered during the live stream. Drying agent, this thing remove residual water in the solution. Okay, and boiling cheat promote boiling by preventing liquid from getting superheated above its boiling point. So now I make it like this so that you can take this, copy this or whatever, and then you can use as a reference. So now we are done here. So okay, so basically that's it for today, live stream number 2, the last live stream with me. So after this there are no more live stream. So any question for those who are still there, who are still around? There are a few persons still around. I don't know whether you are still in front of your phone or camera or whatever. So any question?
No.
Sir. Okay.
Okay, so we will end this live stream. So if there is no question, we will end this live stream with recitation of Umul Kitab. We will end this live stream with recitation of Tasbih Kafarah and Suratul As. And that's it for today.